have any idea about the BGP protocol? Any basic concept? First of all, we will discuss here how I'll teach you here. BGP stands for, can you tell me the full form of BGP?
Border Gate Protocol?
Yes, perfect. Border Gateway Protocol.
Okay,
Perfect. Okay. And you know any point here like what is BGP or why we are using a BGP? Anything else? So what are our criteria, like how I'll teach you here. I'll teach you each and everything in the BGP. See, these are the like all the BGP that we are going to discussing here.
Okay.
Okay. Right now, I think attributes is not there. I also want to write the attributes also as well. Okay, we will discuss attributes as well here. Everything. Okay, so this is all about the BGP. So first of all, we will discuss here why BGP. Okay, and BGP special features, like why we are using BGP protocol, and then we'll discuss the BGP and customer side. So these are the our criteria. So first of all, I'm going to discuss here basic of BGP. Right. So tell me something about the BGP. Any point you have any idea about the BGP? Yeah, please.
Like basics.
Yeah, basics.
Oh well. Oh boy.
Anything else? Anything else you know about the BGP that you told me? Yeah, please.
I know some things about the AS path. That chooses
SAN
the
numbers.
route. I
Mhm.
think that's about it. I don't know anything else. Actually.
Okay, no
Well-
problem. No problem. Yeah.
A question
Okay,
that I was
so
asking, like we were like before, we're figuring out how to know which route normally the BGP takes, and as far as I know, like the shortest route is the one that the BGP always. I don't know. Those are the main things. I don't know. How
okay,
can I say this?
I have a question for you.
Mm-hmm.
If I talk about the RIP protocol, EIGRP, and then OSP, right? So if I ask a question like how many router maximum in RIP protocol I'm using, so it is what? 15, right?
Mm-hmm.
Mm-hmm.
And EIGRP maximum, have any idea?
I don't remember that one.
By default, it is 100.
EIGP.
By default, it is 100, but maximum it will be
Okay.
255. It means by default, when we are enable the EIGRP, right? So the capability will be what? The maximum capability will be 100, right? But
Okay.
if I want to increase, so till 255. Okay, so maximum capability of EIGRP, that is 255, correct?
Okay.
Okay. Now, if I'll talk about the OSPF, so here unlimited hops.
Unlimited.
Yes,
Okay.
here we can use unlimited hosts. And in case of BGP as well, we can use unlimited routers.
Okay.
Okay. So the concern is what? Like everyone know, if I talk about the IGP protocol, IGP, and if I talk about the EGP. So have any idea like what are the difference between IGP and EGP? Yeah.
One is internal, the other one is external, right?
Yes,
Mhm.
perfect. IGP is what? Interior gateway protocol, and EGP is what?
External.
External, right? Superb. So can you tell me some IGP protocols? What are the IGP protocols? The name of the IGP protocols.
Mm,
Let me see.
the name of the IDGP protocols.
IGP protocols name. Yeah.
OSP. You mean Interior Gateway Protocol?
Yes. Correct.
And that includes OSPF, right? OSPF or
Okay.
RIP and everything. Like
OSPF.
everything is RIP.
EIGRP is also
EIGRP
RIP.
too. Exactly.
Okay. And one more protocol,
Well,
that is ISIS.
They still use that?
Yes. Still we are using this protocol. Still we are using an ISPN.
Okay.
Mm.
Yeah.
Because I heard this
So these are,
protocol in the CCNA, but I don't remember using it in real life.
yeah, now this ISIS protocol is not in our syllabus. Okay, and not in the Cisco syllabus actually.
Exactly.
But still, yes. Yeah. But yes, we are using this protocol somewhere. Okay. So these are the
Okay.
IGP protocols, right? And if I ask a question, please tell me the EGP protocol, like exterior gateway protocols.
That could be BGP, right?
Yes, perfect.
Yes.
That is
Every
called what?
BGP system.
BGP. Okay, that is fine.
Okay.
But I have a question for you. I'll make a topology, right? Because you need to know where we are using IGP protocols and where we are using EGP protocols, right? So let's take an example. Here we have some routers, R1, R2, R3, right?
Mm-hmm.
These routers connected to like this. And after that, I'm having R4, right? And R5, and then what? R6, right? Superb. And this is, let's say this is the company, right? Let's say this company uses AS. This company uses AS, and the AS number is what? Let's say that is AS number 10, autonomous system 10, right?
Mm-hmm.
Exactly same. This is one more company, and this company uses what? AS 20, right? Okay. And okay. After that, I'm having here. This is the ISP. ISP 1, ISP 2, and ISP 3. So these all the ISPs connected to each other, and this company is also take a ISP like internet connection from the ISP like this, right? So this is our scenario, right? So in this time, tell me, first of all, my question is what? Where do we use IGP protocol?
Oh, that will be internal. Like
Yeah.
on the
Internal, okay.
Between
So
router
it means we
one,
can
between
say
the routers, between the routers.
between the routers, exactly.
yes, perfect. It means we can say within the AS, right?
Like AS, like for example, AS10 inside you have the R1, R2, R3 inside. You can use
Exactly.
that.
Yes, perfect. So according to this topology, according to this scenario, according to our topology, in like where we are using those protocols, where we are using the IG protocols, we are using those IG protocols in between R1, R2, R3, and R4, R5, R6, right or wrong?
Exactly. Correct.
Perfect. Super. It means here we have power to use a RIP protocol. Here we have power to use a EIGL protocol. Here we have power to use OSPF protocol, right? Because these are the
Yes.
IGP
Correct.
protocols. Super.
Exactly.
And here also RIP, EIGRP, and then what? OSPF. Super.
OSPF. Yeah.
Yes, great. But right now, if I want to communicate from AS10 to AS20, so I'm not able to communicate.
Well, in that case,
Because
you will need BGP, right?
yes, so here I'm not using any protocol. That's why this AS is not able to communicate this AS, right? So obviously in between the ISPs, we need to use a protocol, right? Any protocol. So according to you, you told me right now we are using here the BG protocol, right?
Exactly.
Why? My question is what? Why?
Because
it's
that's the
external,
yes.
external protocol.
Yeah, it's a protocol that we use
Again,
internationally.
I have I told you one thing here. First of all, tell me why we are using a routing protocols.
Why we're using routing protocols?
I think according to me, we are using routing protocol to share the routes from one side to another side. Right? Yes or no?
Yes. From router to router.
Correct?
Exactly.
Yes, perfect. It means if the protocol is RIP, if the protocol is EIGRP, if the protocol is OSPF, if the protocol is BGP. So these all the protocols we are using to share the route. Yes or no?
Yes.
Perfect. So you told me here we are using a BGP protocol, right?
Exactly.
Here we are using what? BGP. But let's say I'm not using BGP. Let's say I'm using OSPF. So what is the problem? We can also use the OSPF.
I was going to ask you why they don't use OSPF or other protocols instead of BGP. What will be the reason why using BGP?
Yes, that is my reason. That is my question actually. Why specially I'm using here the BGP? Because here I'm using RIP, IGRP, OSPF. But why I'm using here the specially BGP protocol? Why?
Because it's a well, it's
Well,
established that it's
it's
the
an
that's why
external protocol,
it's an
but
external
the reason is
protocol.
why.
See again. Let's we everyone know this BGP is a EGP protocol. It means exterior gateway protocol, right?
Exactly.
And
Yes.
BGP is used to communicate to two different aids. But let's take an example. I'm the owner of this ISP, ISP1, ISP2, and ISP3, correct? And let's say I'm using here OSPF protocol. Here also I'm using OSPF protocol. Here I'm using what? OSPF protocol. Still, they will share the route from here to here. So what is the problem? Why we are using a BGP specially? That is my question.
I have no
Isn't
idea.
it?
Actually, that's
Isn't
the
it?
question. That's the question I will have to you. We're replying the question.
Maybe because it's established standard that everybody. I mean,
But again, you told me like there is if some is there is a standard. So obviously in the background of the standard there is any reason. My question is what is the reason?
hmm,
Okay, don't worry, I can explain you why BGP. Okay, see, there are some points here. Because this is the one of the best question for interview, or you can ask for anyone. Okay, because this is the one of the best question. Why BGP, right?
Exactly.
Yeah. Okay. So the first thing, if I'll talk about the IGP protocol, right? IGP protocols support give me a second. Okay, now. So IG protocol support thousands of routes in our routing table. Okay.
mhm.
But if I'll talk about a EGP protocol, EGP, like whatever the EGP protocol, sorry, EBGP, not EBGP, it's EGP. So EGP protocol support lakhs of route in our routing table, right?
What do you mean, super lax?
Uh, it will be supporting more than 1 lakh route.
But what does it mean?
Okay.
Like the lag word, what does it mean?
Okay, it means what? 1,000 and then lakh. Like, okay, I can explain you. If I'll talk about the 1,000, so 1,000 is what? Like maximum it will be supporting what? It means it will be supporting
1,000.
This is 10,000. So if I'll talk about OSPF, right? EIGRP. So those routing protocols will install maximum to maximum thousands of route, or we can say the 10,000 route in the routing table. But if I'll talk about the BGP, so BGP will receive in our routing table more than 1 lakh of route. So this is what 1 lakh. Getting a point?
Okay.
This thing is clear? Yeah. So these IGP protocols don't support lakhs of route, those route in our routing table. Why? Because if I enable the OSPF protocol in any router and EIGRP protocol in any router or RIP protocol in any router, so on that router, the RAM will be reduced, right? RAM and the processor will be lower. But if I talk about when we enable the BGP protocol in any router, right? So on that router, we have more RAM, okay, higher RAM, and the processor is also higher.
Exactly.
Because this is the bigger protocol, right?
Okay.
So this is the first reason we can say, because we know on ISP, I can receive these routes, okay, and I can receive these routes as well on ISP router, right? I'm not receiving those route in our normal company. No, I can receive in our company thousands of route. But on ISPN, right? Yes, I can receive lakhs of route, billions of route in a routing table. So that is the one of the first thing, that's why we are using a BGP protocol. Getting a point on ISP. Okay.
Okay.
So this is the first point here. Okay. And okay, one more thing.
So the first point will be, the first point that you say will be?
What? Can you repeat again?
Yeah. Can you repeat again? The first point will be, what was the?
The first point is what? That is IG. Like if I talk about the IG protocol, so IGP protocol support thousands of route in our routing table, right? And if I talk about the EG protocol, so EGP protocol support
1 lakh.
1 lakh, or we can say lakhs of route. Don't say 1 lakh. Okay, more than lakhs of route.
Okay.
In our routing table, right?
Okay.
Perfect. So this is the one of the first point. Okay, now the second point. Okay. You know the route manipulation. What is the meaning of route manipulation?
Well, you can determine to which path you want to go.
Perfect. It means if I want to switch the path, then yes, we are using a route. The route manipulation, it means if I want to make another path as a best. Let's say, let's take an example. Here we have a router R1. Here we have router R2, R3, R4, and then R5, right? Okay. And what happening? Let's say R2 having a loopback IP that is 2.2.2.2/32, and this R1 wants to communicate this 2.2.2.2, right? So right now we have two paths to reach this 2.2.2.2. The first one that is via R3, right? And the second one that is via R4. So let's say this path is what right now? This is the best path, okay? And this is what? Backup path, right? So let's say if I want to make this path as a best, so this is called what? Route manipulation, right? Perfect. Okay. So in case of RIP protocol, in case of EIGRP, in case of OSPF, you know how to manipulate the path in RIP protocol, how to manipulate the path in OSPF? Have any idea?
I thought that was automatically, right? Or that was with how's it called? The area. The area or something like that. I don't recall.
Yeah, let's say in this time, let's say I'm enable the EIGRP protocol, okay, on R1, on R3, on R4, on R5, on R2, right? So let's take an example. This path is a what? This is the best path, right? Automatically that routing protocol will find the best path, correct?
Yes.
Okay. Now what is the task here? I want to make this path is the best. So have any idea like how many featured in EIGRP to make this path is the best? What feature EIGRP uses to make this path is the best? Have any idea? No?
Because I know OSPF uses the shortest path, but EIRP
Yes.
normally is automatic.
It means we can say OSPF uses shortest path, that is fine, but OSPF will find the shortest path behalf of bandwidth.
Yeah, I was going to tell you that. It depends on the bandwidth of the link.
Yes, perfect. Okay. It means if I want to make this path as the best in OSPF, then what we need to do? We need to change the bandwidth, right? If I'm changing the bandwidth, then yes, the path is manipulated. Exactly same in case of EIGRP. Actually, EIGRP uses what? Bandwidth plus delay. So EIGRP will uses bandwidth plus delay to manipulate the path, and EIGRP uses one more concept, that is offset list. Offset list to manipulate the path, and RIP is also uses
hops, right? Hops.
Yes, offset list to manipulate the path, right?
Okay.
So it means what I can explain you right now, what I'm explaining you, RIP having, if I want to manipulate the path in case of RIP, then we have two features. In case of EIGRP, let's say we have two features. In case of OSPF, to manipulate the path, let's say two features, right? But the one of the best advantage of the BGP, once I'm using the BGP protocol, so we have 12 attributes, 12 attributes to manipulate the path.
Oh, wow.
Getting a point? You know, you told me AS path, weight, local preference in BGP. You heard about these words in the BGP?
Yes.
Yeah, I hear about that.
So those are what? Those are what? Those are the attributes. And using those things, we can manipulate the path in BGP. So this is one of the best advantage of the BGP. When I'm using the IGP protocol, so we have maximum to maximum 1, 2, or 3 attributes to manipulate the path. But in case of BGP, we have 12 things, or we can say we have 12 attributes to manipulate the path. Clear?
Yeah, you have like 12 options to manipulate the route, basically.
Yes, perfect. Okay, so this is the second benefit. If someone asks a question, why I'm deploying the BGP here? So you can say, in BGP, we have 12 attributes to manipulate the path. Very simple, right? Perfect. So the second point, in case of IGP, we have 2 or 3 attribute to manipulate the path. But if I'll talk about in case of EGP protocol, so in case of EGP, we have 12 attributes to manipulate the path. Clear? Super.
Okay.
So this is the second point, right? Okay. Now the third point is what? Okay. I have a question for you, right? What is the question? The question is, let's say we have a router R1, okay, R2, right, and R3. R1 is connected with R2, R2 is connected with R3. And this R1 having this interface F0 by 0, this R2 having two interface F0 by 0 and then F0 by 1, right? And on R3 we have F0 by 0. And let's say the IP address is what? Here I'm using 192.168.10.1. Here I'm using 192.168.10.2. Here I'm using 192.168.20.1. Here I'm using 192.168.20.2. Correct? And let's say R1 router having a loopback IP that is 1.1.1.1/32. Clear?
Okay.
Done. So let's say I'll make this topology and I'll configure the IP address. I'm not configure any routing protocol right now. Okay. So just to tell me, this R3 router will receive 1.1.1.1 route or not right now?
No, you have to create a static routes in that case.
Perfect. Obviously, we need to use any routing protocol, right? Not static.
Yes.
We can say yes.
Exactly.
Using the static, this R3 is also receive 1111 route, but we can say we need to use any routing protocol to receive 111 route to this R3 router. Correct?
Yeah.
Super. So let's say, okay, now let's go on R1. I'll enable the EIGRP on R1. And I also enable the EIGRP on R3. I'm not enable the EIGRP on R2. So just to tell me, can I receive 111 route on R3?
You still need to configure R2.
Because the loopback, I remember, is not part of the routing protocol, right? I think. Isn't it that you have to do like a static route or something?
No, let's say I advertise this 111 route in the EIGRP. So 101% this R1 router will share this route to another router. But my question is what? I'm enable the EIGRP on R1 and on R3. I'm not enable the EIGRP on R2. So this R3 will receive 111 route or not? That is my question.
But question, is the R2 configured as at least a static IP route or not? Nothing's configured.
No, I'm not configure anything else on R2. I'm not configuring anything else. Just I configure the IP address. That's it.
It should not.
Yeah.
Not receive. Obviously, this R3 router don't receive the route. Why? Because you know, once I enable the EIGRP on the routers, so what those routers will do? First of all, those routers will up the neighborship, right? So I'm not enable any EIGRP on R2. I'm enable the EIGRP on R1 and R3. So the neighborship will be down. And if the neighborship is down, so these routers don't share the route to R3, right?
Exactly.
So it means what we need to do? We need to go on R2 and what? We need to enable the EIGRP. Then yes, this R3 router will receive the route, correct?
Yes, because it will broadcast the routing. The
Perfect. They will multicast, not broadcast. We can say they will multicast because it uses the multicast addresses. Yeah, we can say technically a broadcast. Okay, so that is fine, correct? So it means what I can explain you right now. What is my concern? Try to understand. It means when I'm not enable the EIGRP on R2, so this R3 router don't receive the route. But when I enable the EIGRP on R2, then yes, this R3 router will receive the route, correct? It means this is called this type of name. It means what these protocols will do. If I'll talk about the RIP protocol, if I'll talk about the EIGRP, and if I'll talk about the OSPF. So those all the protocols, what those protocols will do, those protocols will forward the route neighbor to neighbor. Again, I repeat the main point. These routing protocols will share the routes neighbor to neighbor router. It means R1 will share to our neighbor R2. R2 will share the route to our neighbor R3. Exactly. So that's why that's why we should to enable the EIGRP on R2 as well. Then only this R1 router will share this route to R2 and R2 router will share this route to R3. It means this type of neighborship is called what?
Directly connected, right?
Direct
neighbors.
Neighborship.
Okay,
this is called what? Direct neighborship. But if I'll talk about the the BGP, let's say we have a router R1, R2, and R3. So what is the advantage of BGP? Okay, one more problem here. Let's say this R1 router having 10,000 of routes. Correct? So those 10,000 route will receive R1 as well. Those 10,000 routes received by R2 as well. And those 10,000 route received by R3 as well, correct? But let's say here I'm enable the BGP. Here the same topology is there, right? Let's say the IP address is what? 10.1, 10.2, 20.1, 20.2, and R1 having a loopback 1.1.1.1/32. So what is the feature in the BGP? Let's say if I'm enable the BGP on R1 and on R3. So yes, this R3 have power to receive this 1.1.1.1. I'm not enable the BGP on R2, but still, yes, this R3 router will receive the route. It means we can say in the BGP will support what? Direct neighborship as well. And the second, we can say
Indirect neighborship. Then.
indirect neighborship. Yes.
So
So
in
this is called
case,
what?
in this case, so if you don't enable BGP on the R2,
What can you repeat again?
yeah, if you don't enable BGP on R2, the R3 will receive the BGP neighbors as well.
Yes, yes, yes.
Okay.
Yes,
But how does it
I can
receive it?
explain you, don't worry. Yeah, I can
how?
explain you, okay? Right now, just I told you the feature of these protocol, like why, what are the advantage of the BGP, right? We will discuss those things, all the things in very depth, don't worry, okay? How this R3 router will receive the route, we will discuss, okay?
Okay.
Yeah, super. So, okay, one more advantage. So what is the profit of this indirect neighborship? The profit is what? Okay, let's say this R1 router having 10,000 of routes. In this topology, this R1 route is also 10,000 route. Those 10,000 route received by these three routers. But in case of BGP, those 10,000 route will receive only on R1. R2 don't receive those routes. R3 will receive those routes. Because R2 don't need those routes. So why this R2 will receive? This is a good thing actually. This is a good thing because let's say R2 don't want to receive those routes. No need to receive this 10,000 of our R2 because obviously when this R2 router will receive the 10,000 routes, so the CPU utilization is higher. And I don't want to receive those routes. Only I want to receive the route on R2 router and on R2 router. So we can say this is the good thing, right? The indirect neighborship is what? This is the good thing actually, okay? So it means just I explain you what in case of IGP protocol, RIP-IGRP, OSPF, these protocol will support direct neighborship. And if I talk about the BGP protocol, so those protocol will support direct and indirect both the neighborship. Clear?
Okay.
Yeah.
Super. So these are the benefits we can say, right? Okay, so we can say IGP will support direct neighborship only. Done? Perfect. And if I talk about the EGP will support direct and indirect neighborship, right? Okay. Okay. I told you one more thing. If I'll talk about within the AS, we are using which type of protocol? IGP, right? Like RIP, EIGRP, and OSPF. These protocol we are using within the AS, right or wrong? Okay. So we are using this RIP, EIGRP, OSPF protocol within the AS. It means what? So my question is what? What is my question? Again, I'll make these three routers R1, R2, R3, and this is the AS, right? AS10. So what I can explain you, I'm using here the protocol what RIP, EIGRP, OSPF, right? Can we use here the BGP protocol? Yes or no?
Wait a second. No, I mean, if it's interior, if you can use the BGP protocol between routers.
Yes, my question is what? Let's say we have these three routers, R1, R2, and R3, and this is the AS10, right? So obviously these three routers within the AS. So can we use this BGP protocol here in between the routers?
No, because it's supposed to be in ASN from ASN to ASN, not from router to router.
Okay, but my question, let's say if I'm enable the BGP protocol on these three routers, so what is the problem?
But
Isn't it the BGP protocol has to have an ASN per router to be configured?
We can say what is the yeah, your answer is correct, but I'm adding some lines here. What if someone says, can we use the BGP protocol on these three routers? So what is the problem? You can say yes.
Oh, but it has to be internal BGP.
Yeah,
we can use these protocols in the routers, But the problem is what? When we enable the BGP protocol on the router, so always we need a high series of routers. We can say high processor in the router. We can say highest RAM in the router. Okay. So we can use the protocol, but actually we know here in these routers, those routers will receive thousands of routes only. So why we are enable the BGP here? When the work is completed using those protocols, so why we are using a BGP? Because BGP will take more RAM, more processor. So that is the reason I'm not using those protocols on within the AS. We can enable, we have power. If I'm enable those protocols, so there is no any problem. But there is no any need actually, right?
Exactly. Because you're gonna need the processing power of each router.
Yes, because let's say we are using in our company the lower series router. Obviously, a company will once the company will use a high series router, so obviously company in the loss. So that's why company will use a lower series of router in our organization, right? So on sometimes what happens, some routers not support the BGP as well.
Exactly.
Okay.
Exactly. Some routers don't support.
It means according to the scenario, it's depend on like we are using or not. If someone say we can enable the BGP, so yes, we can do that, but there is no any need actually, right? That's it.
Can I have a question?
No.
I have a question. Like,
tell me.
How can you enable the routers? For example, let's say each router does it have to have a different ASN, or I can assign it the same ASN to each router, and that's how I can actually configure the BGP internally? This is like, as far as I know, I thought you needed an ISN. ASN number.
just to tell me the scenario. I'll make the topology here, then I can explain you. Yeah.
Okay, no problem.
Can I make some routers here? Yes. Please tell me your question. You ask a question. That question I can explain you in the written format. Then you can understand easily. So just to tell me what is your question, and I'll make the topology according to your question. Yes.
Exactly.
So can I make a topology like this? R1. Hello. Yeah. Tell me. Can you repeat the question again, please?
Okay. For example, you said that we can actually use BGP internally between routers with, I imagine, internal BGP, but does each router need to have an ASN number? And if, for example, let's say R1 has an ASN number assigned, but R2 doesn't, what should I do? Repeat the same ASN?
Okay, let's say your question is what? Each router need a AS number, right?
Yeah, to configure a BGP, right? To configure BGP protocol,
yes.
when we configure
the BGP, when we configure the BGP in any router, so obviously we need a AS number. Yes.
But the ASN numbers, for example, we have ASN numbers that are public because we get it from the LACNIC or from ARIN.
Exactly.
In the internal BGP, we can use which ones? Do you have like a range for internal BGPs? Because I am assuming that the ASN that are public you cannot be used, right?
Yes. Actually, if I look at the AS number, so there are two types of AS number: private and public AS.
Yep, and we already have that. Okay, actually, we have a public ASN already.
Okay. Okay. So your question is what? See, wait. I'll make a topology. Let's say this is the ISP.
We are an ISP. So when we have
okay, you are the ISPs. Okay.
We are the ISPs.
So
and we have two routers.
Wait. Okay, you told me you are the ISP. So let's say this is your ISP.
Exactly.
And in the ISP, you told me you have two routers, right?
We have one router in one city. And on the, let's say R1 we have a connection to the to a provider, to one of the providers that gives you the internet. And we have our ASN, for example. So from R1 you can draw like a cloud which connects to this provider.
Okay, so R1 I'll make a cloud.
Exactly.
Okay.
That's we are connecting to one of the providers, and then we connect R1 to R2 with a fiber optics, which is like around, I will say, how many kilometers, Hector? Like
Okay.
200
So you told
kilometers?
me here we
Yeah,
have one more router.
200
I'll make one more
kilometers.
router here.
No. The R2 is in the other city. R2 is R1 is in one city. R2 is in another city.
Yeah, but
Okay.
they're basically connect between each other through fiber optics.
So can I connect like this?
Exactly.
Yes,
It's
yes,
connected
correct.
like that. Yeah, and imagine it's like 300 kilometers or 400 kilometers, I think, connected.
Okay.
Mhm.
So R1 is connected to one provider. R2 is connected to another provider.
Okay. You told me R1 is having
R3
different
doesn't
provider
exist.
and R2
Exactly.
having a different provider, correct?
Exactly. The ASN is the same on both. The one that we get from LACNIC, which is like a ring from Latin America. So we already have.
Like your question is what? Can we use here the same AS or different AS, right?
Or which
So
one?
it's
If we or if we want to interchange routes or do like a failover, I imagine that we're going to see this in maybe in a few days, because we are thinking to do like a failover or do something inside with the IBGP. Exactly.
Okay, so what is the scenario here? Let's say on R1 I'm using AS100 and on R2 I'm using AS200, right? And you told me in between R1 R2 there are 100 kilometers, let's say, right?
Yeah,
1,000
like
of
200.
kilometers.
All right.
So what's your question? Like the AS will be same or different, right?
Yeah, but what Hector is asking internally, because I am imagining that internally we need to enable the IBGP.
Okay. Yes, if I'm enable the IBGP, so we have the same AS.
And that in that case we can use any AS that we want. Or it has a, like, for example,
You told me like let's say if I'm using IBGP 100 AS here and on R2 I'm using AS 100 AS, right? On R2.
Okay, but do you have like a range for private IBGP, like similar one with the IP addresses? You know that you have private IP addresses and public IP addresses.
Yeah, obviously there is a range. Yeah.
Okay. You cannot
Yeah,
use like
from
the public, I guess.
you
If
can
I'll
choose
talk
from
about
one.
if I'll talk about the BGP, so it is a in BGP we have 16 bit and we have 32 bit as well. In the older, like if I'll talk about the AS number in the BGP, so we have 16 bit AS. Okay. The older routers will support only the 16 bit, but nowadays in BGP we have also 32 bit AS as well. Okay, 32 bit, but these 32 bit AS uses by the new routers, new series routers.
Okay.
So it means we can say 2 raised to power 32 approximate 4 billions of here we have in case of 32 bit AS.
Okay. Understood.
Okay. Yeah. So BGP will support actually, if I'll talk about the EIGRP protocol, EIGRP is also using the AS number, right? But those protocol will support only 16-bit AS number. But if I'll talk about the BGP will support 16-bit AS as well and 32-bit AS as well. Okay.
Okay, but these BGP ASNs are public or private, or we have a range of privates that we can use internally.
For example, Juan Manuel says, like, for example, in XEBGP, for example, external BGP, we use a public ASN, but internal BGP, we can use, for example, ASN 10 and ASN 20. It doesn't matter internally. Or we have to use the same public ASN in both routers. It's like internally.
Okay, it means your
ASN.
question is what? Your question is what? Let's say this is the R1 router. Okay, and this is the R2 router. And here I'm using what? IBGP.
Exactly.
Right. And so here also I'll take let's say this is ISP or whatever. And here I'm using, let's say the AS number will be what? 200, right? And here I'm using AS number what? 100 and then 100, right?
Exactly.
So your question is what, like or we can say like that as well. Here I'm using 300 as well. So
Okay.
actually, this is not possible. This is not possible. We can use in any router. We are using only one AS number on BGP, single AS number.
But that's for
We
internal
cannot,
BGP or for
like,
external BGP?
yes, for internal we are using 100, right? So it means we
Okay.
are using a command. We are using command router BGP, right? And then say what 100, correct? And now
That's
let's say,
internally.
if what do you think? What do you think? Let's say here I'm using one more AS, that is 300. So once you enter the command here, now router BGP 300, so it will be show you an error. They don't accept this
Mm.
command.
Okay, so you can use only one ASN per router. You
One
cannot
AS
use
for
two.
each. Yes, normally we can use only one AS, but we have a one more feature in the BGP, that is AS migration. In
From
that case,
ASN
yes,
to
we can use that. Okay.
okay, from one ASN to another ASN, basically.
Yes, for AS migration, this is also a topic of your BGP, so don't worry, we will discuss this topic. Okay.
Sure.
Okay.
Yeah. Yeah. But normally, I also show you when you enable any AS in BGP, and if you are enable one more AS in the BGP, the different AS, so they don't accept. The router don't accept. In case of EIGRP, let's say on the same router I'm using AS10, and on same router I'm using AS20. So yes, in this case it will accept. But in case of BGP, we can enable only one AS on a particular router. Okay.
Okay.
Yes. Yes. So I hope the discussion about the BGP is good, right?
Mm-hmm.
Yeah, that's great. Now let's discuss something. Okay. Now let's discuss some point. So, RIP is the distance vector routing protocol, right? EIGRP is the advanced distance vector routing protocol. And if I talk about the OSPF, so OSPF is a link state routing protocol, right? Exactly. If I talk about the BGP, so BGP is what? Which type of protocol? Have any idea?
Oh, path vector. Okay.
Yes, it is a path vector routing protocol. Okay. Okay. If I'll talk about the RIP protocol, so RIP is a layer 7 based protocol, right? And EIGRP and OSPF is a layer 3 based protocol. So have any idea BGP is a which layer protocol? Layer 7, layer 3?
It has to
Should
be
be
layer 3 protocol, huh?
layer 3, right? Yeah.
No, it is a layer 7 protocol.
Really? Oh my god.
What? Oh,
Yeah.
wow. So it's a basic.
Well,
Yeah.
it's
If
not
I'll talk about RIP, so RIP is also a layer 7, right? RIP is also a layer 7. And if I'll talk about the EIGRP, so EIGRP is a layer 3 protocol. If I look at the OSPF, so OSPF is also layer 3 protocol. And the BGP is what? Layer 7 protocol. Okay.
Hmm.
How? I can also prove you how. Okay, I can explain you one thing here. This is a very important thing as a network engineer. See, I can explain you one thing. You know what is port number? We have some port numbers, right?
Mm-hmm.
Okay. And then we have some IP address, and we have a MAC address. Okay, tell me MAC address is below which layer? Layer 2, layer 3, layer 4?
layer 2.
Perfect.
Mm-hmm.
And IP address belongs to?
Layer 3.
Layer 2,
Superb.
3.
And port number is belongs to?
Layer 4, right? I think.
Yes, it's a layer 4. Yeah. Superb. And we have in layer 3, we have one more thing. That is protocol number. So it means at layer 4, we have a port number. Okay. At layer 4, we have a port number. At layer 3, we have a IP address and protocol number. And MAC address having like at layer 2, we have a MAC address, correct? Okay. That is fine. If I'll talk about, if I ask a question, please tell me what is the protocol number of EIGRP? So that is 88.
Oh, protocol port number
Yes,
or
if
protocol
number, right? Yes.
okay.
Protocol number of OSPF protocol. So that is what? 89. Okay. And this EIGRP is a very important thing I can explain you. Okay, you can just to see here, you can understand automatically. Okay, yeah. So EIGRP is a layer 3 protocol, and it is a layer 3 protocol. OSPF is also correct. Okay. And if I'll talk about BGP, so BGP is what?
You mean the number of the protocol number?
Have any idea what is the port? What is the port number of EIGRP?
Port number of EIGRP.
Yes.
I don't remember that.
179.
No problem.
179.
No. That is for EIGRP. Sorry, that is for BGP actually.
It's
actually
port number is 88.
You are confused. You are confused.
It's 88. The port number of EIGRP is 88, no?
88. No, it's a protocol number.
But the port number is also 88, no?
No. Why? Actually, you guys, you are confused. I'm telling you the technical thing here. How you can understand the protocol and port number. Okay. See. Actually, it is what? It is a layer 3 protocol, right? Okay. And if I'll talk about the BGP. So BGP is what?
Layer 7.
Right? Yes. And tell me the RIP.
RIP is layer 7.
Yes, RIP is also what? Layer 7. Perfect. That is good. Superb. It means if I'll talk about EIGRP protocol first of all. So EIGRP is a which layer of protocol? Tell me. EIGRP is a layer 3 protocol, right?
Yeah.
Okay. So what actually EIGRP will do once I'm enable the EIGRP? So what this EIGRP will do? First of all, this EIGRP will add our header, right? EIGRP header. After that, EIGRP will check I'm a which layer of protocol? Tell me. Layer 3. So it will be adding what? Layer 3. After that, it will be adding what?
Layer 2.
Layer 2. After that, it will be adding what?
Layer 1.
Layer 1.
Superb. So tell me guys, on layer 3, we are using what? IP address and what? Protocol number, right? Here I told you. Right? Okay. And at layer 2, we are adding what?
MAC address.
MAC addresses, and layer 1 will convert one into the 1010 format, right?
Those are bits, yeah.
Yes, bits format, correct. So just to tell me, here in this EIGRP, we are using any layer 4?
No.
No. And port number belongs to which layer?
4.
Layer 4.
So can you tell me EIGRP have any port number? No.
Right. You're right.
Getting a point?
Yes, that's your point. It doesn't have a port number.
So this is the technical thing
4.
actually. layer OSPF protocol is don't have any port number, and EIGRP protocol is don't have any port number, because these are the layer 3 based protocol. It means these protocol don't use layer 7 and layer 4.
Okay, 4. Got it.
According to this concept, EIGRP and OSPF protocol don't have any port number. It means when the protocol is layer 3 based, those protocols don't have any
Port numbers.
port number. And if the protocol is layer 3 based, then what? Okay, I can explain now. Let's say I'm using a BGP. So BGP is what? It is a layer 7 based protocol. So first of all, BGP will add our header. After that, it will check I'm a layer 3 based protocol. So it will be adding what? Layer 7. Then it will be go what? Layer 4.
Layer 6.
And at layer 4, we know we are adding what? Port number. And it will be go after that layer 3. And then what? Layer 2. And then what? Layer 1. It means this protocol will use port number as well as the protocol.
Okay.
It means once the protocol is layer 7 based, so those protocol will use port number and then what? Protocol number both. But when the protocol is layer 3 based, then this protocol will use only the protocol number. Clear?
Okay, understand.
Now it is clear. Super. So now I hope this is clear to you. It is a layer 7 based protocol. Why I'm saying it's a layer 4? Because you told me it is a layer 3 based protocol. So if it is layer 3, so it means we have only port protocol number. We don't have port number. But yes, BGP having port number. If the BGP having port number, so 101% it's a layer 7 based protocol. Correct?
Okay.
So it means we can say it uses TCP port number. What? Tell me. You told me 170.
179?
Yes, it uses TCP. If it is a TCP, so we can say it is a very reliable protocol. It is a very reliable protocol. Okay. And by default, you know, if I'll talk about EIGRP, RIP, and OSPF, so those protocol will support by default the load balancing, right? But if I'll talk about the BGP, so by default BGP don't support what? Load balancing.
Bummer.
Yes. Okay, but yes, if you by default they don't support. If you want to enable the load balancing, then yes, we have a command to enable the load balancing. We will discuss later those things. Don't worry. Okay.
So it doesn't support, but there is a way to do load balancing or not?
By default they don't support. By default it is not enabled. But if you want to perform a load balancing in the BGP, then yes, we can do that using the command.
Okay. Good.
By default, they don't support. If I talk about the RIP and EIGRP and OSPF,
Actually,
so those protocol will support by default. No need to enable that. But in case of BGP, by default, it is not supporting. If I want to performing a load balancing, then yes, we have a command to enable that. Okay.
Okay. Actually, this is what was one of the questions that we were going to ask you maybe later on the course, because we need to do some load balancing as well.
Yeah, sure. We will discuss the load balancing as well in this course. Don't worry. Okay.
Excellent.
Yeah. See here, I'll write here the BGP load balancing. This is the command. Okay, so we can do that. Don't worry. Okay, we will discuss these all the things. Don't worry. Okay. And yeah, guys, please add some points here for me. Tell me some extra point here for the BGP.
Extra point.
Yes.
Well, we already got the BGP. Layer 7, it has port, reliable by default. What else? I don't know, maybe It can handle millions of
Okay,
routes.
we can say that here it is what? It is a classless routing protocol. Okay, guys, have any idea, anyone? What are the difference between classless and classful routing protocols?
Nope.
Okay. Okay, I can explain you first that thing. First of all, if I'll talk about RIP, so RIP having two versions, right? Version 1 and then version 2. And then here we have EIGRP, and then here we have OSPF, and then what? BGP. So if I'll talk about the RIP version 1, so it will, there are two types of types of routing protocols, classless and classful. RIP version 1 is what? Classful, and remaining all are the classless. This is also classless, classless. This is also classless. This is also classless, correct?
Okay.
So what is the difference between like classless and classful? I can explain. Let's say here we have a R1 router and here we have a R2, 10.1 IP, 10.2 IP, and this R1 having IP address 1.1.1.1/32. Okay, so first of all, just to tell me this 1.1.1.1/32 is a classless IP or classful IP?
What was the question again?
Okay, my question is what? This 1.1.1.1/32 is a classless IP or classful IP?
Has to be, I would say, classful.
This is the classless IP. How I can identify? Just to check the IP address. IP address belongs to which class?
Oh, this is IP. Oh, class A. Oh, class A.
And this is what? D. So it means both are
Okay.
different class. So if we have different class, so it's a class less IP. If we have 1.1.1.1/8, so this IP address belongs to class A. Subnet mask also belongs to class A. If it is same IP and subnet mask, so this is what? Class less IP, correct?
Okay, okay, I get it now.
Yeah. So according to this, if we have a IP address 1.1.1.1/32, so this is what? Class less IP, correct?
Exactly, because it doesn't belong
Okay,
to the
super.
same.
Now let's say on R1, I'm enable what? RIP version 1, and on R2 I'm enable what? RIP version 1, correct?
Okay.
And RIP version is what? Classful or classless? It's a classless, classful routing protocol, right?
Okay.
So in this case, what happened when I enable the classful routing, when I enable any classful routing protocol? So what happened? Those protocol will send the update. And inside the update, it will be share 1.1.1.1. They don't share any subnet mask. It means they don't share this /32, correct? And if I'll make the same topology here, on we have R1, we have R2, or R1 router, we have IP address 1.1.1.1/32. And let's say on R1, R2, here I'm enable what? Version 2 and version 2, right? So once I enable the version 2 on both device, then this device is also sending what? Update. In this update, inside this update, it will be sharing what? Subnet mask as well. So in the classful routing protocol, what is the difference between classless and classful? Whenever the classful routing protocol will share our update, so they don't add the subnet mask. Whenever the classless routing, any classless routing protocol will share the update, so they will add the slash value as well, correct?
Okay, okay.
So this is the difference between actually the classless and classful. It means classful routing protocol don't share the subnet mask. Classless routing protocol will share the subnet mask, right?
Okay, got it.
Actually, what happened? Once this R2 router will receive this update, so it will be checking, okay, I'm receiving right now 1.1.1.1, and we don't have any subnet mask, right? So what this R2 router will do, this R2 router will check, okay, we don't have any subnet mask. So what this R2 router will do, this R2 router will check this 111 IPs belongs to which class? Class A. So automatically it will be adding here /8 subnet mask and add this route in the routing table like this. So actually this is the confusion, because actually the route is what? 1.1.1.1/32, and R2 router will install this route in the routing table like this. So this is the problem actually in the classful routing protocols. And in classless routing protocol, they will share the subnet mask. It means once this R2 router will receive the route 1.1.1.1/32. So exactly same route, it will be installed in the routing table. Clear?
Okay, understand. Perfect.
Yeah. So this is the difference between the classless and classful.
Okie dokes.
Okay. And if I'll talk about by default, auto summarization is disabled in BGP. Okay. And the important thing is what? You know, if I'll talk about OSPF and if I'll talk about the EIGRP protocol. So whenever these protocol will send any packet on any update, so it uses what? Multicast address to share any update. If I look at the EIGRP, so EIGRP uses 224.0.0.10 and OSPF uses two multicast addresses 224.0.0.5 and 224.0.0.6. But if I'll talk about the BGP, so BGP will send, it means we can say in case of EIGRP and OSPF, whenever those protocol will share any packet, so it means we can say that packet is what? Multicast packet. That packet is called multicast packet. But in case of BGP don't send any multicast packet. Always BGP will send what? Unicast packet. Okay. It means we can say BGP don't support dynamic neighborship. Okay. BGP will support static, or we can say, yes, static neighborship, or we can say.
What is the difference between the dynamic and the static?
Yeah, I can explain you. Yeah, BGP will support static, or we can say manual neighborship. Manual neighborship.
I think static sounds better.
Okay. So what is the difference? You told me like static and dynamic neighborship. If I'll talk about the EIGRP protocol, right? So let's say we have some routers, R1, R2, and then what? R3, correct? And here we have a switch. F0 by 0, F0 by 0, F0 by 0. And let's say here I'm having IP address 10.1. Here I'm having IP address 10.2. And here I'm in 10.3, right? And on R1 having a loop back that is 1.1.1.1/32, correct? This thing is clear now? Okay. Now let's say I'm enable the BGP, sorry, I'm enable the EIGRP on these three routers. Okay. So let's say EIGRP, and EIGRP. So once I enable the EIGRP, what this R1 router will do, this R1 router will send an update to this switch. And inside the update is look like this. In this update, the source IP will be 10.1, that is exit interface IP, because the packet is exit from here. So the source IP will be that is exit interface IP 10.1. And the destination IP is what? It uses multicast address 224.0.0.10. So the destination multicast address is what? 224.0.0.10. This thing is clear? Any doubt? And inside this update packet, we have a IP 1.1.1.1/32 because it's a classless routing protocol. That's why it will be sharing /32. So this is the update, right? Okay. Just to tell me, on R1, I'm not saying here on R1, please make a neighborship with R2 and make a neighborship R3, right? I'm not saying to any my concern is what I'm try to understand. On R1, I'm not saying please make a neighborship with R2 and please make a neighborship with R3. I'm not saying like that. Okay. Just what I can do right now, just I can send this packet. What I can do, just I can send this update packet. Okay. So this switch will receive this packet, and this packet is called, this is called multicast packet. Why? Because the destination IP address is what? That is multicast address 224.0.0.10, correct?
Mm.
Okay. Now whenever switch will receive any multicast packet, so actually switch don't know the multicast, switch will know only the broadcast and unicast. So what this switch will do? This switch will broadcast this packet to both interface, correct? Okay.
Mm.
So switch will send this packet to R2 and switch will send this packet to R3, right or wrong? Okay, just to tell me, on R2 I'm enable the EIGRP or not?
Mm.
Yes, my question is what? On R2 I'm enable the EIGRP or not?
Yeah, you said you did enable that.
Should be.
Well, you don't have to actually. But
Yes,
well, yeah.
obviously I enable the EIGRP on R2 and on R3, correct? Okay.
Mm-hmm.
And right now this R2 will receive this. So my question is what? I can receive the update. So my question is what, this R2 router will accept the update or not? Yes, obviously it will be
Mm-hmm.
accepting. Why? Because this update is come from where? From EIGRP. And I also enable the EIGRP on my router. So it means this R2 will accept the
You mean,
update, right?
okay, you mean if it is enabled, you should be receiving the update.
Yes, if it is not enabled, then they don't accept.
Exactly. Okay.
Okay. Yes. So it means right now this R2 router will accept this update, right? It means once this R2 router will accept the update, automatically this R2 will show me, okay, this R2 will show me I have a neighbor. That is what? 10.2. In the table, it will be show me I have a neighbor 10.2, correct? So it means, right? And exactly same thing, once this switch will send the update to R3. So on R3, I also enable the EIGRP. So yes, R3 is also accept the packet. And once this R3 will accept the packet, again, it will be show me we have a neighbor that is 10.3, correct? Right or wrong? So it means
Yes.
right now, automatically this neighborship will be up.
Mm-hmm.
On R2, I'm not saying please make a neighborship with R2 and please make a neighborship with R3. Statically, I'm not saying. Automatically, the neighborship will be up. So this type of neighborship is called what?
Dynamic.
Dynamic neighborship. This thing is clear? And let's say, now let's go on R2. Now remove these all the things. Now what happened? EIGRP is also supporting two types of neighborship. Dynamic neighborship and static neighborship as well. Okay. So previously I'm using what? Dynamic neighborship. So let's say in static neighborship, what happened? Statically on R2, we need to say, please make a neighborship only on with 10.2. So in this case, what happened? Whenever this R1 router will send the update, so the source IP will be 10.1, destination IP will be, because it is a statically, I'm saying only make a neighborship with R2. So the destination address is what? 10.2, and inside this update 1.1.1.1/32. It means this R1 router will send the update to switch. Okay, switch will forward this update to R2 and to R3 as well, but R3 router don't accept and R2 router will accept this update. So this is, now on R1 it will be show me I have only one neighbor, that is what? R2. So this type of neighborship is called static neighborship, because statically I'm saying my neighbor is only on 10.2. I don't want to make a neighborship with R3.
Okay,
But when I'm using
where-
a normal command, so that is when the device will use a multicast address, right, at the destination, that is what? That is dynamic neighborship. Yes, tell me.
Okay, but where do you configure that, on R1?
What?
Where do you configure that part on R1? How
Okay.
R2 is going to accept that routing table, that update?
In this time, what happened? In this time, I enable the EIGRP on R1, and I also enable the EIGRP on R2. But statically on R1, I'm saying only make a neighborship with R2. I'm using a command here, the neighbor command, neighbor 10.2, like this.
Okay.
Okay. In the dynamic neighborship, actually, I'm not using a neighbor command. Okay. On dynamic neighborship, we are using a network command. Okay. But let's say if I want to make a static neighborship with only with R2, and I don't want to make a neighborship with R3. So on that case, we are using a neighbor command. I'll say neighbor only 10.2. So the device will send a source IP, our exit interface IP, that is 10.1, and the neighbor IP, that is here I mentioned here 10.2. So the destination will be 10.2, and it will be share the route to this R2 only, right?
Okay.
So this BGP is also supporting a static neighborship. Actually, they don't support the dynamic neighborship. EIGRP will support static and dynamic both, but BGP will support only on the dynamic neighborship. Sorry, static neighborship. Clear?
Okay.
Perfect. Okay, so have any idea the AD value? What are the AD value this BGP uses? Anything else? How many types of AD value in the BGP?
What is the ID?
Yes, AD value, administrative distance.
Oh, administrative distance.
Okay, if I look at the IBGP, so in IBGP we have what? 200, right? In case of EBGP, we have what? 20, correct? So there are two AD value. When I'm receiving any route from my IBGP neighbor, so the AD value will be what? 200. When I receive any route from my EBGP neighbor, so the AD value will be 20. Clear?
Okay.
Okay. Yeah. Perfect. And now if I'll talk about
So it's 20.
20.
200 EBGP 20.
Now let's discuss here what types of neighborship. So have any idea how many types of neighborship in BGP?
No idea.
Okay, it's very simple. IBGP and EBGP.
Only two. Okay.
Yeah. So this is what actually this is not a. If see, there are two things. If someone say there are two types of BGP, no, this is a wrong word. The BGP is not a two type. There are neighborship. This is what IBGP neighborship and EBGP neighborship. So that's why I'm saying it's a types of neighborship. This is not a types of BGP. No. If someone say this is the BGP type, IBGP and EBGP, this is type. No, this is not a type. This is a neighborship type. Okay. So, okay, can you explain me what is the difference between IBGP and EBGP?
IBGP is internal and EBGP is external.
Okay, let's say we have a router, right? So how you can explain anyone this is IBGP or this is EBGP? Let's say here we have router R1, here we have router R2, and R1 having IP address 10.1, R2 having IP address 10.2. Here I'm using what? AS 100, right? And here I'm using what? AS 100. So this is, tell me, in between R1 R2, this is IBGP or EBGP?
IBGP.
This is IBGP, right?
Because they're using the same ASN, the same
Yes, within the
AS.
AS, same AS. Perfect. And exactly same. Let's say if I'm using on R2, let's say if I'm using a 200, in this case,
EBGP.
EBGP, right? This is what EBGP. Okay, that's great. So it means what happening? Let's say on R1 router, we have a IP address, we have a loopback IP that is 1.1.1.1/32. And once this, let's say I'm enable the on R1, I'm using BGP 100 AS, and on R2, I'm using BGP 200 AS. Now, once this R2 router will receive this 1.1.1.1 route, so tell me what AD value it will be show me here.
I'm sorry, what was the question?
What AD value it will be show me? 200 or 100? Sorry, 200 or 20?
It's supposed to be 20 if it's if it's EBGP.
It will be 20. Are you sure?
If it's EBGP or it's
Yeah,
IBGP.
I don't know. I don't know it is EBGP or IBGP. You can check because here I'm using
Oh,
AS
it says
100
it.
and
Oh,
here I'm
yeah,
using
it's
AS
20.
200.
Yeah, it's 20 because it's EBGP.
Yes, it is EBGP. That's it will be show me here what 20. Superb. And let's say if I'm using here what the same AS that is 100. In this case, it will be show me what AD value
200.
200. Superb. Okay. Okay. So let's start a small practical here. Guys, give me a second.
Sure.
Yeah. Okay. So let's do the practical. And let's make a small practical first, then you can understand. So let's say we have two routers, R1 and then R2, correct? And R1 having IP address 192.168.10.1, right? And on R2 having IP address 192.168.10.2, correct? And 1.1.1.1.1 on R1/32. And on R2, we have what? 2.2.2.2/32. Guys, till now, everything is okay, like my teaching method and all. This is comfortable for you. Guys, can you hear me?
Yes, yes.
Yeah, what I'm saying, everything is like perfect here. My teaching method and all, you can understand each and everything, or can I change my
Yes,
teaching
yes.
method? Or
No. So far, so good.
superb. Okay, thank you. Okay, so right now I have two routers, R1 and then R2. On R1 we have this IP address, and on R2 we have this IP address 10.2, and we have one loopback on both the routers. So let's start the device and configure the IP address first of all on R1. Done. Okay, now I'll show you do show IP interface brief on R1. So can you tell me, on R1 we have this physical interface IP 10.1, 192.168, and we have one loopback, right? Okay.
Mhm.
Now let's go on R2.
Did you configure that just now?
Yes.
No, I'm not configuring BGP right now. I'll configure IP address. That's it. Now let's go on R2 and then say F0 by 0. 10.2.255.255.255.0. And on R2, the loopback will be 2.2.2.2/32, correct?
Mhm.
Done. So IP address configuration will be done. Now let's enable the BGP. So how to enable the BGP? The command is what? Router BGP and then say shift question mark. Can you see here? I told you BGP having what? The AS we have in BGP, this is 16-bit and 32-bit as well, right? So this is what range of 16-bit and this is what range of 32-bit, right? So I'll take here what, let's say 100. Okay.
Okay.
And
Do
I'm
you
saying
want us?
here?
Do you want us to follow you on the lab as well? Because I already have installed.
Hello, your voice is breaking. Can you repeat again?
Because I already have the GNS3 also installed in my computer.
Do you want us to do?
Okay, no.
volume?
You receive any you receive any lab access right now or not?
No.
Okay, not now. Okay, wait.
We can follow you.
Okay. So you have GNS3 in your laptop?
Yes.
Mm-hmm.
Okay, that is fine. That is good.
So maybe we can follow along.
So you are making the same topology like me
Already. Yeah.
Okay. So you can do that, no problem. First
Okay.
of all, assign the IP.
How did you configure the loopback?
Okay, the command is, I'll show you, wait. The command is exactly same like IP address configuration. The command is interface loopback 1 and then say IP address 1.1.1.1 255.255.255.255.
That will be in router 1 interface loopback 1 IP
Yes.
address 111.225.225.225.255.
Yes, correct.
Okay. And on the other one is R2, right?
Yes. On R2.
222. Okay. Interface loopback 1 IP address 222. Okay, done.
Done. Okay, that's great. Perfect. Now let's go on R1 again. And now I'm enable the BGP on in between R1 and R2. So what is the command? I'm saying what router BGP and I'm using AS number 100, let's say, right? Okay. And I'm saying what neighbor. Okay. 192.168.10.2 because what is the IP address of R2?
2.
10.2.
Yeah.
So that's what I'm saying here 192.168.10.2 and I'll say the remote AS. So let's say on R1, I'm using a AS number what? 100. Okay. And on R2 as well, I'm using a same AS, right? 100. So what we need to say here, remote AS will be what? 100, correct?
Mm-hmm.
Okay.
Okay.
Hold on.
Now let's go on R2. Yes. On R2, we need to say what? I'm saying what router, BGP, and then say what AS number will be what 100 or 200. On R1, on R2, I'm saying what 100, and I'll say my neighbor is what 190 to 168.10.1, and then say remote AS will be what 100. Guys, can you see here? Once I'll say enter,
Okay.
so it will take some time. And give me a second. See, can you show? Can you see here? It will be show me a log, right?
Can you show me? Okay, that's the configuration. Okay, never blah blah blah. Remote. AS 100.
Can you see here? It will be show me a log here, right?
Uh-huh.
So it means the BGP neighborship will be what?
Up.
Up. Done. Your neighborship is also up or down right now?
Hold on, almost there.
Okay. Do.
So what is the command to actually check if it is up or down?
Perfect. This is
the
the
log.
one of the troubleshooting command actually. Okay. Right now the BGP neighborship is what? But in real network, let's say if you are using a same command and still the neighborship is not up, or it is up or not, so how to verify? So if you want to verify the neighborship is up or not, so we have two commands. The first command is what?
Show IP BGP.
No, the first command is what? Do show IP BGP summary. And second command is what? Do show IP BGP neighbor. Okay. So I'm using, see, first of all, see here. Okay. First of all, see here. Don't do on your side. I'll show you first. So I'll give you a time to do from your side. Okay. See, on R1, just to use do show IP BGP summary. So this is the command, right? So I'll say enter here. So guys, can you see here? It will be show me state will be what? Blank. State, they don't show me anything else here, correct? If they don't show me anything else here, so it means your neighborship is up properly, right?
Okay.
This thing is clear. How to verify the neighborship is up or not? So just to use this command, do show IP BGP summary, and just to check the state, right? It will be show me right now the state will be what? Blank. So it means the neighborship is up properly, correct? Any doubt?
Well, in my case, it says active.
Perfect. It means your neighborship is down.
Really? Okay, let me see something.
Yes. Why? I think you are doing a wrong configuration. You configure the BGP on both the side, both the router.
Hold on, let me see something. I don't have ping. I think something with the IP address.
Okay, yeah, you can do, no problem. Okay, first of all, just to see here, okay, I'll give you time to do in your laptop. Don't worry, okay?
Okay.
Because these are the very basic and important things. Okay, so this is the one of the command to check the what? To check what? Neighborship is up or
BGP.
not, right?
Okay.
Yes. So it will be show me what? The state will be what? Blank. It means the neighborship will be up properly. And now I'll show you the second command, right? The second command is what? Do show IP BGP neighbor.
Okay, now it's
right?
now it's up in my case.
Neighbors. Yes, perfect. Do show IP BGP neighbor and then say enter. So okay, can you see here? It will be show me my neighbor is what? 190 to 160.10.1. Okay, and the remote AS is what? My neighbor AS, what AS number my neighbor uses? My neighbor uses what AS number? 100. And it is IBGP or EBGP. How you can verify? It will be show me what? Internal link. It means what? This is what? IBGP.
Oh,
okay. And it will be show me BGP state is what? Established. It means the neighborship is up properly, right? That's it. So these are the two commands that we are using to check a neighborship.
Hold on, that one is show IP. Show IP.
Yeah, you can also use this command on your side. Who will do the lab? Who are doing a lab? John, you are doing a lab?
I am.
Okay. So the neighborship is up now?
In my case, yes, it is up.
So
I had
great.
the interface was shut down.
Okay.
Why in the show IP BGP?
The command is do show IP BGP summary. Use the command do show IP BGP summary. If you want, so can you share the screen?
Hold on, because I haven't. I'm doing the lab in another computer.
Okay, no problem, no problem.
Okay, there it is. Okay. Yeah, it's up.
Use the command do show IP BGP summary. This command do show IP BGP summary.
Yeah.
So it will be show you the state will be blank.
Now it's working. Yeah, it's blank now.
So it means now the neighborship will be up. And use the second command as well. Do show IP BGP neighbor.
I did that one too. Yeah, it's working.
Okay, that's great. So can we go to the next?
Yeah.
Okay, so that's it. So this is what like this we are making a neighborship in between the BGP, right? Okay, one more thing. Right now on both the side, I'm using the same AS, right? So let's do one thing. Let's go on R1 and just to disable the BGP again, do just to say here what? No router BGP and then say 100 on R1 and exactly same command on R2. I'll say what? No router BGP and then say what? 100. And let's enable the BGP on both the router again. So let's go on R1 and then say what? Router BGP, say 100. Okay, now on R1 I'm using AS 100, but on R2 I'm using what? AS 200, correct?
Okay.
Okay. Now just to say neighbor 190 to 168, 10.2, and the remote AS will be what? Tell me.
Hold on.
What?
No router, BGP 100 in both, right? In both routers. Okay.
No, on both, on R1 I'm using 100, on R2 I'm using 200.
Yeah, now or 100. Okay.
So just to tell me here, neighbor 190 to 160, 10.2, and what remote AS I need to write, like 100 or 200?
200.
200. No.
200 because the neighbor, yes, because the remote AS will be 200. I'll say enter. Now on R2, I'm saying here what router BGP and then say 200. And here I'm saying neighbor 190 to 168, 10.1.
100.
And the remote AS will be what?
100.
100 and then say enter. So wait for a second. Automatically it will be show me a log and the neighborship will be up. Perfect. The neighborship is up.
Boom.
Right? So can you see here? Here I'm using what? AS 100 and here I'm writing what? AS 200. It means what? It means this is what? eBGP neighborship because I'm using a different AS. If the AS will be same, then it means what? iBGP, right?
iBGP, exactly.
Okay, that's great.
Okay, let me see something. Remote as blah blah blah. Hold on. Do show around. Okay. BGP remote as. Okay, now it went up. It took a couple of minutes to go up for the BGP to start exchanging. Okay, now it's fine.
Can you check the neighborship as well? The neighborship is up or not? Don't don't depend on the log. After making a neighborship, always you can check the do show IP BGP summary command. Okay.
Yeah, that's what I did. Is now it's up.
Okay, that's great. Perfect. Okay. Give me a second. Guys, give me a second. I'll stop the screen sharing.
Okay.
Okay, now. This is done. Okay. Now I can explain you what.
Oh, now it shows external link with the IP BGP neighbor.
Yes. Yes. Once you use this command now, then it will be show you external. Superb. Because it's a eBGP, right? I also show you here as well. Do show IP BGP. Do show IP BGP neighbor. Now it will be show me what here?
External.
It will be show me external link.
Okay.
And the remote AS will be 10.2, and this BGP state will be what? Established, and the remote AS will be what? 200. Correct? Fine. Super. Now I'll show you one more thing. One more thing is here. The basic. If I'll talk about IBGP TTL value. So it uses what? 255. If I'll talk about eBGP TTL value, so it uses what? 1. What are those TTS value or TTL values, and what are the uses that we will discuss later? Okay.
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 Just right now I write here IBGP detail is 255. eBGP detail is what? 1. I also show you here. I think it will be show me. Okay. Do show IP BGP neighbor. Done.
Okay.
Okay. If you make IBGP neighborship and check same here, so it will be show you 255.
Okay.
And it will be show me the foreign port number is what? 179. So yes, one more concept is there in the BGP actually. Okay. I'll show you in R1. The command is what? I think the command is what? Okay. TCP. Can you see here?
What is this command
Okay,
for?
just to tell me, the command is what? Do show TCP brief. Okay, I can explain you one thing here, that in the command is do show TCP brief.
Okay.
So using this command, what it will be show me? Okay, just to tell me first of all, where I'm enable the BGP first, on R1 and on R2. Where I'm enable the BGP first, on R1 on R2. I enable the BGP
R1.
first on R1, right?
Mm-hmm.
And then enable the BGP on R2. So what it will be show me? So at the source side, always it uses a random port number. At the destination side, it uses what? 179 port number. Clear?
Okay.
It means if I'll show you the same command on R2, okay, I'll show you on R2 as well. Do show, do show IP brief. No, what is the command?
Show TCP.
Do show TCP brief. do show TCP brief. So can you see here? Now here it will be show me the source port number will be what? That is 179, and the destination port number is what? The same port number that we are using here at the source, right? It means always how you can verify who is the initiator, like where I'm enable the BGP first. How you can verify? You can verify using this command, because once the because the initiator having a source port number is random port number. Okay, it will be show me the destination port number 179 here. It means we can, if I want to verify where I'm enable the BGP first, so using that we can verify. Here I'm using what? Random port number on R1, and on R2 I'm using 179 port number. So like this, and if I'll show you on R2, so here it will be show me 179, and here it will be show me this. Okay, it means what I can explain you, the initiator having a source port number is random. Let's say this is the initiator, that's why it will be show me 1 2 3 4 5, and the destination port number it will be show me here what? 179. And once this R2 will return back the packet, so the source port number is what? That is 179, and the destination port number is what? 1 2 3 4 5. Okay.
Okay.
Yes. So it means the initiator having a source port number, that is random port number. Okay. Randomly anything it will be choosing. Okay. I'll show you again. Router BGP. This thing I also verify you. Now disable the BGP. No router BGP. Okay. Now, okay. Previously, what I can do, I enable the BGP first on R1. Now I'm enable the BGP on R2 first, right? So I'll say router BGP and then say what? Sorry. On R2, I'm saying what? Router BGP and then say 200, and then say neighbor 192.168.10.1, and then say remote AS will be what?
It's 100.
100. Okay. On R1, I'm saying router BGP say 100, and then say remote AS will be what? 10.2, and the remote AS will be what here? That is 200. Now the neighbor should be up. Give me a second.
Yeah, we'll take maybe a couple of minutes or seconds.
Yeah, perfect. Now the neighborship is up. Now if I'll show you in R2, do show TCP brief. So it will be show me now the random port number. It will be show me on R2, because R2 is the initiator, right? First of all, I'm enable the BGP on R2, and the destination port number will be what? 179. And on R1, do show IP. Sorry, do show TCP brief. Correct. Done. Okay, super.
Okay.
Now, guys, do one thing. Let's take a small break, a tea break, right? I think.
Tea break.
Okay, so right now, you are from which country?
I am in US, and Hector is in Dominican Republic right now.
Yes.
We have the same. Actually, we have the same.
So right
time.
now in your country, it's morning, right?
It's 12. Yeah.
It's lunch. It's almost lunch break.
Okay. Okay. So what is the timing right now?
12.
It's
12. Yeah.
Okay. Okay. Perfect.
So where are you, in India right now?
Yeah, I'm from India. It's a night.
Oh.
What time is it now?
Yeah,
We have like 12 hours difference, like 8 hour difference, or 10 hours difference?
Yeah, I think it's 10-hour difference. Okay, so guys, what we can do, we need to take a small break, right? So I'll start the clock here. Give me a second. So now we can start at 9:40. Okay.
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 So 40 minutes break, basically.
Well, 15 minutes.
15 minutes break.
All right. Perfect.
Okay.
See you in a couple of minutes.
Okay, dokes.
Yeah. See you later. Guys, shall we start?
I'm here. I don't know if Hector is here. Hold on.
Hello.
I'm here.
I'm
I'm
here.
here.
Okay.
Yeah. Okay. I'm back. So shall we start?
Yeah.
Okay, that's great.
Yep.
Now, now I can explain you what BGP messages. So guys, have any idea how many messages in the BGP or any, any message name?
Well, will be a lot, right? Should be a lot.
No idea.
No? Okay, no problem. The first one, that is what? Open message. Okay, the second one. Open message. After that, keep alive.
Close message. Oh.
Keep alive.
Yes. And then here we have update message. And then here we have what? Notification. Okay. So first of all, I can explain you the open message, right? So open message is used to establish the neighborship. Okay. Open message is used to establish the neighborship, right? Or we can say once I enable the command, once I enable the BGP, so at the first time, the device will send which message? The device will send open message. Clear? Okay. If I'll talk about the keep alive message, right? So keep alive we are using for which? Keep alive we are using what?
Like a refresh or something like this? Like we're trying to keep alive the connection?
To
maintain
the neighborship.
Exactly.
I can explain, don't worry. Okay, I can explain you. Okay, so first of all, I explain you the open message, right? Now, before explaining the BGP open message, first of all, I can explain you the IGP protocol's hello messages. Okay. Let's take an example. We have a router R1. And then what R2, right? R1 is having 10.1. R2 is having 10.2. R1 is having what? 1.1.1.1/32. R2 is having 2.2.2.2/32, right? Okay. So what happened in case of IGP protocols? Like I'm talking about all IGP protocols, EIGRP and OSPF, right? So let's say if I'm enable the let's say if I'm enable the EIGRP on R1. if I'm enable the EIGRP on R1 and on R2, so what happening? Immediately this R1 device will send what?
The hello message.
Hello message, right? And R2 is also sending what? Hello message. Okay. So both the device will send the hello messages. Okay. And after sending the hello message, what both the device will, like R2 will receive a hello message from R1 and R1 will receive a hello message from R2. So once it will be received, then both the router will match the hello parameters. Okay. Both the device will match the hello parameters. Once the hello parameters is matched, once the hello parameters is matched, then the neighborship will be up. Once the hello parameters is not matched, then the neighborship will be what?
Down.
Down. So let's say the neighborship, the hello parameters will be matched. After matching the hello parameters, what those device will do? Both the device will make a neighbor table. Okay. This R2 is also making our neighbor table and R2 is also making our neighbor table, right? Okay. So after making a neighbor table, what happening? R1 will show you, R1 will show you what? R1 will show you I have a neighbor 192.168.10.2 and R2 will show me in the neighbor table. It will be show me what I have a neighbor 192.168.10.1. Clear? Okay. And actually, if I'll talk about the EIGRP hello timer, so have any idea what is EIGRP hello timer? That is 5 seconds actually. And the hold down time will be that is 15 seconds. Clear?
Okay.
Okay. So actually, this R1 router will hold the neighborship till how many seconds? 15 seconds, or we can say equals to hold down time. Right now, the hold down time is what 15. So it will be hold this neighbor till how many seconds? 15 seconds, and here also 15 seconds. Clear? Okay. And what happened once the neighbor is hold in the neighbor table, then the timer is going on like this: 14, 13, 12, 11, 10, 9, 8. Okay. So once it will be reached like 14, 13, 12, 11. So it means 1, 2, 3, 4, 5. 5 seconds is finished, right? Again, this R2 router will send one more hello packet. Because I told you after how many seconds it will be sent the hello packet?
5.
5 seconds. So again, this R2 router will send a hello packet to R1. Now again, the timer is refresh and it will be reach 15. Now it will be again, it starts from 15, 14, 13, 12, 11. Again, this R2 will send because R2 will, both the device will send after 5 seconds this hello message. Again, the timer will be reached to 15, 15, 14, 13. So like this will up, like the neighborship will be up. It means we can say using the hello timer, automatically once the device will receive a hello timer, then automatically the timer will be refreshed and again the neighborship will be up, right? But let's take an example. After some time, this R2 router goes down, right? R2 router goes down. It means R2 router is not able to send any hello packet to R1, right? Now the timer is what? 15, 14, 13, 12, 11. Once it will be reached 11, then it will wait. Okay, I'm not receiving any hello packet. Now the timer is what? 10, 9, 8, 7, 6, 5. Still I'm not receiving any hello. Then it will be what? 4, 3, 2, 1, and then 0. Once it will be reached the 0, then it will remove the neighbor inside the neighbor table. Clear?
Yes.
So it means in the EGP product, like in EIGRP, what happening? Why we are using hello packet? This hello message or this hello packet will doing a two task. First is what? To establish the neighborship, right? Second is what?
maintain
a neighborship. Right or wrong? In case of IGP protocols, in case of OSPF and EIGRP, this hello packet will establish the neighborship and to maintain the neighborship. It means this hello packet will doing a two task, right? But in case of BGP, what happening? Let's say we have a router R1 and we have a router R2. Here we have IP address 10.1. Here we have IP address 10.2. Okay. In this case, what happening? Let's say if I enable the BGP on R1 and I also enable the BGP on R2. So what happening? Immediately the device will send what? The device will send first of all. Okay. In this time, in case of IGP protocol like EIGRP and OSPF, immediately the device will send the hello packet once you enable the protocol, right? But in case of BGP, what happening? Once you enable the protocol, then first of all, both the router will establish what?
Here.
TCP connection.
Okay.
Because it is a TCP based protocol. That's why. Correct? It means what happening? This R1 device will send what? SYN packet. SYN, synchronization. You know, three-way handshaking process.
Yes, the three-way handshake.
Yes. So once you enable the BGP, so first of all, both the device will doing a three-way handshaking process. R2 will send what? SYN and then what? Acknowledgement. And R1 will send again what? Acknowledgement. Once this TCP connection is complete, then the device will send what? Open message. R1 will share open message to R2. R2 will share the open message to R1, right? This thing is clear. It means once this three-way handshaking process is complete, then the device will send an open message. If it is not completed, then the device don't send any open message. Clear? Okay, great, perfect. And now this open message, why the device will send the open message? In this open message, what are the content inside the open message that I can explain you, don't worry. So it means we can say the first packet is what? Once you enable the BGP. So first of all, both the device will complete the TCP handshaking, three-way handshaking. Once the handshaking will be finished, then the device will send the open message. Okay. So this open message basically we are using to establish the neighborship at the first time. It means first of all, the device will send what? Open message. Now it means the neighborship will be what? Established, right? Now the device will send again one more packet, that is what? Keep alive. That is what? Keep alive. Okay. So this keep alive message, both the device will send in every how many seconds? 60 seconds. 60 seconds. So these open message we are using to establish the neighborship, and this keep alive message we are using to maintain the neighborship. Getting a point? Because in every 60 seconds, the device will exchange the keep alive message. So in the IGP protocols, hello message will doing a two tasks, establish the neighborship and to maintain the neighborship. But here for establishment, we have an open message. For maintaining a neighborship, we have a keep alive message. I hope this is clear to you now.
Okay.
Any doubt?
Nope.
Super. Okay. Now what is update message that I can explain you later. Okay. So open is done. Keep alive is done. Okay. Now I'll show you these packets practically. So I'll show you first of all. Let's go on R1. Do show IP BGP summary. Okay. No router BGP and then say 100. And on R2, no router BGP and then say what 100. On R1, I'll say what router BGP. And okay, right now I'm not enter the BGP. I'll capture the packet here, right? So right now these are the normal packets, right? Now let's go on R1 and let's enable the BGP. I'll say what router BGP 100 and then say neighbor 192.168.10.2 and then say remote AS will be what? That is 200. Okay, let's send both the side. I'm using the same AS, right? And here I'm saying what 100. And on I'm not saying enter right now. Just I write the command. I'm not saying enter. Okay, and let's go on R2. And here we need to say what router BGP and then say what 100 and then say neighbor 192.168.10.1 remote AS will be what 100. Now I'll say 100, right? So on both the side, I'm saying 100 and 100. I'm not saying enter right now. Now I'll say enter on R1 and I also say enter on R2, right? Okay, so after entering these, what happened? Wait for a second. I'll show you the packets. See, the device will send the packets. Now I'll stop these packets. So can you see here?
Okay.
Yes. Can you see here these three TCP messages? So this is what SYN.
This
is what SYN and ECK. Yes, this is what three-way handshaking process. So it means once you enable the BGP, so these are the three packets. It means the device will exchange the device will doing a three-way handshaking process, right?
Okay.
And once the three-way handshaking process is complete, then the device will send what?
The open message and keep alive.
Open message, right? R1 will send the open message first, then R2 will also send the open message. Then R2 will send again what? Keep alive message. And R1 is also sending a keep alive message. Okay, done. Now I'll show you what are the content inside the open message. So I'll open this. Inside the open message, what are the contents? So these are the contents. Like first of all, it will show the version, right? It means what happening once both the device will send the open message. So how the device will identify this is IBGP neighborship or this is EBGP neighborship using this open message, because inside this open message, can you see here? Inside the open message, the version is also there, BGP version 4, right? And AS number, my AS is what? That is 100. And what is the hold down time of the BGP? That is 180, right? And it will also share the optional parameters. Okay. So these are the things that the device will share. Okay. What happened? Okay. Right now, inside the packet, the AS is what? That is 100, right? Okay. Inside right now, R1 is also using AS what? 100. Okay. And this R1 is also using AS what? 100. And I can receive also the AS from the neighbor, that is what? 100. It means this is what? IBGP, right? And if here it is what? If it will be show me here what? AS will be what? 200. And on R1 I'm using 100 and neighbor router I can receive inside the open message I can receive what? AS what? 200. So it means what? This is what? EBGP, right? So it means we can say how the device will decide this is IBGP neighbor or EBGP neighbor using this open message. It will check the open message and check the AS number. If it is same, so it is IBGP. If it is different, so it is EBGP, correct?
EBGP, yes, correct.
Yes, and this is the type code of open message, that is 1. Okay, that's it. Okay, now I'll show you the keep alive message. So open message, first of all, both the device will send the open message when the open message parameters will be matched. Then the device will send what? Keep alive message. Okay. Now I'll show the keep alive message. So inside the keep alive message, nothing else. Okay. Here just these are the content inside the keep alive. Okay. There is no anything inside the keep alive message here. And every 60 seconds, the device will send a keep alive message. And what is the opcode of that is what 4. Okay. The type code is what that is 4. Okay. So this thing is clear. Keep alive and open message is done. Clear. Guys, any doubt till this point? Anyone?
No. We're fine.
Okay, that's great. Super. Okay, that is good. Now the 2 messages also there. Update message, right? Okay, I can explain you update message later. Okay, don't worry. Okay, now I can explain the open message first. So this is the topology, right? Okay. Now what happening? Let's go on R1. On R1, I'm using a network command, right? I'm saying 1.1.1.1 mask 255.255.255.255. Once I'll say enter. So can you see here? Immediately the device will send what? Update message. It means when the device will send the update message, whenever I'm using which command? Network command. Okay. Once we are using a network command, immediately the device will send what? Update message. Now I'll show you the update message. I'll stop these packets and I'll show you the update message. Okay. So this is the update message. Inside the update message, there are multiple contents. What are the contents? Okay. First of all, this is the type code of open message, right? After that, total path attribute length. And after that, it will be showing path attributes. You know, BGP uses path attributes, origin, AS path, next hop, multi, okay, med, multi exit, and local preference, right? So these are the attributes. It means whenever the device will send the update, whenever the device will send, when I'm using which command? When I'm using what? Network command. So what the device will do immediately? The device will send what? Update. And inside the update message, first of all, we have what? Attributes, right? So the device will send what? Attributes, first of all, right? So inside the open message, we have all the attributes. After that, inside the open message, one more thing, that is NLRI, network layer reachability information. What is this NLRI? Okay, normally what we are calling in EIGRP and OSP, we are saying what? Routes. And we are saying what? Prefix. Right or wrong? We are saying what? Prefix and route. But in the BGP language, these routes and prefix we can call what? NLRI. It means this R1 router will share this NLRI to R2. This thing is clear? What is NLRI? If someone asks a question, so NLRI is nothing. NLRI is, we can say the routes or we can say the prefix. But in the BGP language, in BGP, we don't say routes and prefix. In BGP, we can say what? NLRI. Clear? Network layer reachability information. Yes or no? This is clear or not?
Yes.
So it means if let's say actually what happened, I also attend the CCI lab. So on that CCI lab, what happening? On that CCI lab, what happened? The interviewer asked a question and he's writing the NLRI. He's writing what? NLRI. So don't confuse what is NLRI. NLRI, it means it is what? Routes, or we can say prefix. Okay. So it means this R1 router will share that route, and the route is what? That is 1.1.1.1/32. See, this is a classless routing protocol because it will share the subnet mask as well, correct? I also told you same thing, right or wrong? Yes. Okay. So yes, guys, have any doubt till this point? Anyone? So this is what update message, right? Inside the update message, the device will send the real routes, right? It means, let's say this R1 router having 1000 routes in the routing table. So once you use a network command, then the device will send the update message. Inside the update message, the device will share those routes. Okay. It means If the router wants to share any route from one router to another router, then it uses what? Update message. Clear? So we have first message. First message is what? Open. Why we are using open message? Tell me.
Gives you the ASN. You can see if it's IBGP or EBGP.
Establish
Gives
the
you
neighbor.
attributes.
Establish the neighborship, we can say, right? Second, we have what?
Keep alive, maintain the neighbors.
Why we are using keep alive?
Maintain.
Yes, to maintain the neighborship. The third one, that is
Update.
Update. Why we are using update?
To update routes and networks.
To share the
networks.
An LS.
NLRI, or we can say to share the routes, or we can say to share the prefixes, right? After that, we have the last one, that is notification. What? That is notification message. Okay, message, open message, keep alive, and then what? Update. Update we are using to share the NLRI, and we can say routes, and we can say what? Prefix. Notification. Once the neighborship down or any wrong configuration we will do, then the device will send the device will send what? Notification message, right? Okay, I also show you here. Let's go on R1 and I'll say no router BGP and then say 100, and on R2 I'll say what? No router BGP and then say 200 or whatever the 100, right? Okay, let's go on R1 and then say what? Router BGP, say 100, say neighbor 192.168.10.2, right? And then say remote AS will be, let's say on R2 I'm using what? 200, correct? On R2 I'm using what? 200. So here I'm using 200. Okay, on R2 I'm using router BGP, say 100, and then say neighbor 192.168.10.1, and then say remote AS will be what? 100. So I'm doing here the wrong configuration. Can you see here? Now it will be immediately, it will be send what? Notification. Why it is wrong configuration? Because here I'm saying my neighbor is what? Can you read this line? My neighbor is what? 200. But 200. Neighbor on neighbor I'm configure what? BGP AS what? 100. 100. So this is the wrong configuration. Yes, that's why the device will show me what? The notification message, right?
No. Okay.
So I hope the notification is also done, right? Once I'm or wrong configuration will be done, then device will send what? Don't say like this. Any wrong configuration? Then the device will send notification message. Clear?
Correct.
Guys, still now have any doubt in the messages, in the BGP messages?
Yeah,
I hope this is clear to you, right? Okay. See, this is the notification message. Notification type 1. See, it will be show me what is the problem here. The problem is what? Open message, bad peer AS. It means the AS problem is there, because on R1 I'm saying my neighbor is what? My neighbor AS is what? 200, but on R2 I'm using AS 100. So that's it will be show me bad peer AS. Okay. Bad peer AS, that is 100. That's why it will be show me this log. Okay. Now let's go on R1 and just to disable the BGP, no router, BGP, and then say what? 100. And on R2, no router, BGP, and then say what? 100. Correct? Guys, till now, I hope everything is clear to you, right? The BGP messages done. Okay, great. Now we'll discuss here what? BGP, neighbor command, and BGP network command. Okay, so first of all, I can explain you the BGP neighbor command. Then I can explain you what BGP network command. Clear? Okay. Now, so first of all, I can, before starting these commands, first of all, I can explain you the IGP protocols. In case of IGP protocol, right? So let's take an example. We have two routers, R1 and then R2. R1 having a IP address 10.1 and interface will be that is F0 by 0, 10.2, and that is F0 by 0. Okay, on R1, we have 1.1.1.1/32. On R2, 2.2.2.2/32. Correct? Okay, R1 having 10.1, R2 having this, right? Now what happening? Let's say on R1, I enable the BGP. Sorry, I enable the EIGRP, right? So once I enable the EIGRP, so what is the command? The command is what? Router EIGRP 100, or let's say it is 10. Okay, and then we are using what command? Here I'm using what? Network command. Network 192.168.10.0. Exactly same on R2. I'm using what? Router BGP. Sorry. On R2 as well, I'm enable the EIGRP. So I'll use what? Router EIGRP, and then say what? 10. Network 192.168.10.0. Clear, guys? So once I'm using this command, so this network command will doing a two tasks. First, to establish the neighborship, right? Second, this command we are using, first is what? We are using this command to establish the neighborship. Second, we are using to share the prefix. It means after using this command, what happening? The neighborship will be what? Up. This is the first work. And the second is what? This R1 router will share this prefix to R2. Clear? Yes, guys, this thing is clear to you, everyone, you both. So what is the network command? Why we are using a network command here? This network command will doing a two tasks. First is what?
Establish.
Second is what?
To share prefix.
Yes, great. But in case of BGP, what happening? In case of BGP, let's say again we have a router R1 and we have a router R2. R1 using what? 10.1. R2 using what? 10.2. Correct? Okay. Now on on R1, let's say I'm having a loopback that is 1.1.1.1/32. On R2, 2.2.2.2/32, correct? Okay. Now let's go on R1 and then say what? Router. And let's say on R1, I'm using a BGP AS what? 100. And on R2 as well, I'm using what? BGP AS what? 100. It means this is what? IBGP or EBGP? This is what?
IBGP.
IBGP. Perfect. Now on R1, I'm using a command router BGP and then say what? 100. And I'm saying what? I'm using a neighbor command. Neighbor. Who is my neighbor? I'm saying my neighbor is what? 192.168.10.2, right? Exactly same on R2. I'm using what? Router BGP and then say what? 100 and then say what? Neighbor. And neighbor is what? 192.168.10.1. In this time, what happened? In this time, the device will send, once I'm using a neighbor command, the device will first of all do the three-way handshaking process. Then it will be sending open message. Then it will be sending notification, right? So in this time, the neighborship is what?
Up.
But the device don't share any route. It means this R1 router is not sharing this route to R2. No. In case of IGP protocol, once we are using one single command, that is network command, so device will doing 2 tasks to establish the neighborship and to maintain, and to second is what? To share the prefix, right? But in case of BGP, if I'm using a neighbor command, then it will up the neighborship. It will make the neighborship. It will establish the neighborship, but they don't share any prefix. And if they don't share the prefixes, then R2 router is not able to communicate with 1.1.1.1. Yes, sir. Because R2 router is not receiving 111 route in the routing table, right?
Until you add the network on the router, right? Like when you put the command network
now
111.
Yes, if I want to share route in the BGP, because BGP is a very different protocol compared to IGP protocol, compared to EIGRP and OSPF. In case of EIGRP, OSPF, we are using one single command, network command, to share the prefix and establish the neighborship, right? But here, if I want to share the routes, then we have a different command, that is what? Network command. Here I am using a network command. I'll say what? Network, and then say what? 1.1.1.1, and then say what? Mask 255.255.255.255. In this time, immediately the device will send what? Update message. And in this update, we have a route that is 1.1.1.1/32, right? It means in case of BGP, we have a 2 command. First command, that is neighbor command to establish the neighborship. Second command, that is network command to share the prefix, correct? Yes, tell me. Have any question?
Yeah, but this is like a manual procedure. Well, what if you get the prefixes from the internet, which are like maybe 1 million prefixes? How do you redistribute these prefixes to another router? Because you're not going to do it manually, right?
Are you saying if we have, yes, manually we need to do. If we have, no. Actually, what happening? Let's say this router, this prefix I'm not receiving from any another router. No, this prefix, let's say this is the R1 router prefix. Okay, so if I want to share this prefix, then we are using network command. If we have 10 IP addresses, if we have 100 IP addresses on R1, and if I want to share those routes, so yes, manually we need to use 100 commands, 100 network commands. Okay. Clear or not?
Yeah.
You have any question? If you have any question, so yes, just to ask. Yeah, please.
No, but you say manually that you have to add the 100 prefixes? No, right?
Yes. If this router having 100 IP addresses on 100 routes, like, okay, what happening? Okay, let's take an example. Here we have a router, one more, that is R3. R3 is connected with R1, right? And R1 router having how many prefixes? Let's say R1 router having 10 prefixes, correct? And R1 is also receiving 10 prefixes from R3, correct? So in this time, what happening? Let's say on R1, I'm not using any network command on R1. So in this time, R1 router will receive 10 prefixes from R3, right or wrong? And R1 router is also having 10 prefixes, correct? So in this time, R1 router will share only 10 prefixes to R2. And what those prefixes that I can receive from R3, that prefix only this R1 router will share to R2. R1 don't share these 10 prefixes to R2. If I want to share these 10 R1 prefixes, then we need 10 network commands on R1. Then this R1 router will share this prefix as well, right?
Okay, but the ones from R3 are going to be redistributed to automatically, right? Or I don't know.
No need to do any redistribute or anything else. Let's say here also I'm using a BGP, right?
Exactly.
So if I receive any route from my BGP neighbor, so that prefix I can share immediately, right? But if I want to share my self-advertised prefixes, then we need to use a network command.
Okay, that is if you have your own IP addresses in your router.
Yes, correct. Absolutely. Yeah.
Okay, I understand.
Okay, yeah. Perfect. So it means now the command is clear, right? It means neighbor command we are using to establish the neighborship or of the neighborship. Network command we are using to share those prefixes, correct?
Yep.
Okay.
Now let's do the practical and then it is clear to you. So let's go on R1. Okay. I'll say here what router BGP, do show IP BGP. So there is no any BGP right now. So first of all, we need to enable the BGP. So I'll up the neighborship first of all. So I'll say what router BGP 100 and I'm using right now the iBGP neighbor. So both side I'm using the same, right? And I'm using first of all the neighbor command that is 10.2 and then say remote AS will be what 100. And let's go on R2 and then say what router BGP and then say what 100 neighbor is what 192.168.10.1 remote AS will be what 100. I'll say enter. Yes, the neighborship is up, right? The neighborship is up. Okay, one more thing I can explain you. If I'll talk about the tables, so can you tell me how many tables in the BGP? Have any idea?
On which one?
Routing tables?
Okay, routing table first, okay. But this routing table having all the routing protocols like RAPI, GRP, OSPF. This is not like any specific table. So have any specific table in the BGP? That is BGP table actually.
So it's like kind of
so in BGP, what?
It's separated. Like routing tables is one thing, BGP tables is another one.
Yes. They both are the different actually. Routing table is a different thing and BGP table is a different thing, correct?
Okay.
Routing table we can say this is the global routing table.
Oh, okay. Yeah, global.
Okay. And after that we have a BGP table, right? In the BGP table we have only the BGP routes. BGP routes available in the BGP table, right? Okay, I'll show you, then you can understand. Okay, right now, I'm not using any network command, right? Only the BGP neighborship is up. It means the device don't share any prefix to each other, right? Okay, now I'll show you first of all the routing table. Do show IP route. So it will be show me what these are the routes, correct? Right or wrong? Okay. On R1 it will be show me that by default router will install the directly connected route. So it will be show me 10.0 network is available in the routing table and R1 is also having a loopback that is 1.1.1.1, correct? So it will be show me right now 10.0 and then 1.1.1.1 inside the routing table, right? Exactly same thing. If I'll show you on R2 router routing table, right now I'll show you guys routing table, not the BGP table, right?
Okay.
Yeah.
So on R2, yes, on R2 if I'll show you, so R2 it will be show me do show IP BGP, do show IP route. I'll say enter. So here it will be show me the directly connected networks that is 10.0 and then 2.2.2.2, correct? Right now this R2 router don't receive 1.1.1.1 route. That's why I'm not able to communicate to this 1.1.1.1, right or wrong?
Okay.
And if I'll show you R1 router routing table, so R1 router don't receive 2.2.2.2 route. That's why R1 is not able to communicate with this 2.2.2.2. Clear?
Mm-hmm.
Okay. Now, okay. Now, okay, I'll show you the routing table, right? Routing table is done. Okay. Now I'll show you the BGP table. How to check the BGP table? The command is what? Do show IP BGP. Okay, I'm saying enter. See, they don't show me anything else. Why?
Hmm.
They don't show me any route in the BGP table. It means using the BGP protocol, we are not sharing any route. Okay, if I'll show you R2 router do show IP BGP, so they don't show me any route in the BGP table, right? Okay, now let's go on R1 and then say what router BGP say 100 and then say network 1.1.1.1 mask will be what 255.255.255.255. It means what we are doing. I'm using a network command. It means after enter this command, what happened? This R1 device will send the update to R2 and it will share this prefix 1.1.1.1 towards R2, right or wrong?
Exactly.
Perfect. I also show you here the packets right now. They will send in every 60 seconds. They keep a live message. Once I'll say enter. So can you see here the device will send immediately the update message, right? And inside the update message, what information is available? The route is what? That is 1.1.1.1/32, correct? It means this R1 device will send this route. Now again, if I'll show you, do show IP BGP. See, inside the BGP table, it will be show me 1.1.1.1. It means when it will be show me the route in the BGP table when we are using a network. Okay. And I'll show you the same on R2. Do show IP BGP. So yes, it will be show me this 111 route in the BGP table as well, right or wrong?
So now you can ping the loopback from the R2 and backwards.
Yes. Now if I'll show you the routing table as well. So in the routing table as well, I can receive 1.1.1.1 route. From where I can receive this route from? B. And B is what?
BGP.
BGP, right? And which type of BGP? IBGP, EBGP? Can you tell me?
What's up? Let's see. That's 200. Another one.
IBGP, because the AD value will be 200, and when I'm getting the AD value will be 200, when I'm receiving any route from my IBGP neighbor, right or wrong?
Oh, wait.
Clear?
It's supposed to be EBGP.
No, I say IBGP, right?
Yes. This route I'm getting from IBGP, that's it will be show me the AD value will be what 200, correct?
Well, is it? Wait a second. Oh, the both ASNs are 200.
Yes, both are the same AS. Yeah.
Oh, okay, but what is it? 100 or 200? Because it says 200 here.
No. On R1 it is 100 and on R2 it is 100.
Okay.
I will also show you. Do show IP protocol. Okay. R1 uses R2 uses what?
100.
And R1 is also uses
100. Okay.
right.
So why does it says 200 in the previous message? I don't know why.
IBGP AD value is what? 200, right?
Yeah.
Oh, the distance, right. Advertise distance. Okay, yeah. You're right. Okay,
yes,
got it.
Okay.
Now, yes.
And EBGP.
So that's where it shows you the dist. Okay, so
once
that's where it shows
once
you
the AS will be different, then it will be show me here 20.
20, and then it'll be exactly. Okay, got it.
Yes. Yeah. So okay. So R2 router now the route it show me the route in the BGP table as well as the routing table, right or wrong? It will be show me this 111 route in the routing table as well. And if I show the BGP table, do show IP BGP. So yes, it will be show me this 111 route in the BGP table as well. Correct. Now, if I'm doing a ping 1.1.1.1, so yes, I'm able to communicate, right? Okay, let's go on R1 and I'll show the routing table. Do show IP route. Can I receive any 2.2.2 route from R2?
No.
No. So right? What we need to do now?
Go to the
perfect. We need to advertise that using the network command that route, right? So we need to say what router BGP and then say 100 network 2.2.2.2 255 255 255 to 255. Say enter. Now if I'll show you again the BGP table, do show IP BGP. So yes, in the BGP table it will be show me 111 as well as 2.2.2.2, right? And now if I'll show you on R1, do show IP BGP. So it will be show me here as well in the BGP table 111 and 222. Now if I'll show the routing table, do show IP route. So yes, it will be show me 2.2.2.2 route. So I can receive this route from B. B is what? That is BGP. And it will be show me the AD value will be what? 200, correct?
Okay. Yep.
Now if I want to communicate to this 2.2.2.2, so yes, I'm able to communicate, right?
Perfect.
Yeah. So guys, I hope this is clear, like the network command meaning and the network command work and neighbor command work and neighbor command meaning, right? Super. Okay. One more thing I can explain you here. Okay. Guys, can you see here on R1? Do show IP BGP and then say enter. So 11111, I can receive this route, and here it will be show me what next hop IP, right? So it will be show me what next hop IP will be what?
0.00 what?
0.0.0.0, correct?
Uh-huh.
Yes, and for 2.2.2, it will be show me the next hop IP will be what?
Yeah, 192.168.10.2.
Yes, perfect. It means what? When it will be show me the next hop IP will be 111, it means it is a self-advertised route. But when it will be show me the next hop IP, it means this route I can receive from my neighbor. This is not a self-advertised, but this when it, so how you can identify this route is self-advertised or this route I can receive from anywhere using this next hop IP. If it will be show me the next hop IP will be 0.0.0, so it means I'm using I can advertise this route as a self using the network command, right? This thing is clear? Okay. Yes or no?
I think so, yeah.
Okay, super. Okay. That's it. So the use of network command is done. The use of neighbor command is done. Now let's go what? Why BGP is done? BGP feature is done. Basic of BGP is also done. Customer type right now I'm not discussing, so we'll discuss later. BGP port number concept is also done, right? And IBGP, EBGP, AD value, why this is done. Network command and neighbor command is done. BGP message is done. Now let's discuss IBGP loop prevention mechanism. Okay. Right now we will discuss what here now. We are discussing IBGP loop prevention rule, or sometimes we can also call split horizon rule in BGP, right? Okay. So guys, these are the very, very, very important things in the BGP because these are the basics. Okay. So please remember these all the things. Okay. Now, BGP loop prevention mechanism is what? And what is this? Both are the same thing. Actually, the name is different. Okay. What BGP says when a router will receive any route from the IBGP neighbor, so same route not shared to next IBGP neighbor. Okay, the rule is what? Can you read this line? When a router will receive any route from IBGP neighbor, so same route, same route not shared to next IBGP neighbor. Clear? It means what?
Okay.
It means what? On R1, I'm using AS what? 100. On R2, I'm using what? AS 200. On R3, I'm using what? AS 300. Clear? No, I'm sorry. On R2, I'm using what? 100. On R3, I'm using what? AS 100. Clear? Okay. Now, it means the in between R1 and R2, the neighborship type is what? ABGP or IBGP? IBGP? IBGP. Okay. Now what happening? What IBGP says? Let's say this R1 router having a route that is 1.1.1.1/32, right? Okay. So let's say on R1, I'm using a network command. Using a network command, what I can do? I can advertise this route 1.1.1.1 and the mask will be 255.255/32, right? So immediately what happened? This R1 router will share this prefix to R2, right or wrong? It means R2 router will receive this route 1.1.1.1 from R1, right? Okay. And right, just to tell me this R2 router will receive this route from which type of neighbor? IBGP neighbor or EBGP neighbor?
IBGP neighbor.
IBGP neighbor, right? So right now this R2 router will receive this route from an IBGP neighbor. So same route I'm not able to share to my next IBGP neighbor. It means this R2 router is not able to share this route to R3. Clear? This is actually the rule. And this is called what? Split horizon rule. And we can say IBGP loop prevention mechanism or IBGP loop prevention rule. What these routers will say, whenever if I receive any route from my IBGP neighbor, so same route I'm not able to share to my next IBGP neighbor. Clear?
Okay.
This is if it is IBGP, right?
Yes, this is in case of IBGP.
Okay.
Okay, it means if I'll make a topology for you like R1, R2, R3, and then R4, right? On R1, I'm using what? AS 100, right? On R2, I'm using what? AS 100, right? Okay. On R3, I'm using what? AS 100, right? On R4, I'm using what? AS 200, correct?
Okay.
So it means in between R1 and R2, tell me which type of neighborship is there? IBGP or EBGP?
IBGP.
This is IBGP.
Perfect. And in between R2, R3?
IBGP.
In between R2, R4?
EBGP.
Perfect. EBGP. Now what happening? Let's say this R1 router having a route 1.1.1.1/32, and using the network command, I can advertise this route. So what this R1 router will do? This R1 router will share this prefix to R2 1.1.1.1/32. Now R2 router is not able to share this route to R3, but yes, this R2 router will share this route to R4. Why? Because what is the IBGP loop prevention mechanism is what? When I'm receiving any route to my IBGP neighbor, so same route, I'm not able to share to my next IBGP neighbor. But yes, we have power to share those route to my next EBGP neighbor, correct? It means yes, this R4 will receive this 111 route 101%, but R3 router is not able to receive this route. Clear?
Okay.
Interesting. Okay, let me write that down 1 second. Very important.
Okay, this is the very, very, very important rule.
So how do you fix that in case we want the R3 to receive that route?
Yes, R3 don't receive this route. Yes.
Never, 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 never.
Never, never. But in sometimes, okay. Right now this is actually the rule, right? This is what rule. This is what IBGP loop prevention mechanism, right? But when this R3 router not receiving this 1.1.1.1 route, so how this R3 router wants? Let's say this R3 router wants to communicate 111, and I'm not receiving that route. So how I can communicate? I'm not able to communicate to 111. So this is the problem, right?
Yeah.
So don't worry, we will discuss this problem, okay, later. But right now, just I told you the rule, okay, that's it, okay. Now, one more topology. Okay, the question is what? The question is what? Why this rule is created actually? Why? Why we are creating this rule? Because what happening? Okay, let's take an example. We have a routers. We have a 3 routers, R1, R2. What is the problem in the IBGP actually? The problem what happening? Let's say we have this topology, correct? Okay. And on R1, this R1 router having a route 1.1.1.1/32, correct?
Yep.
Okay. Let's say on R1, I'm using what? Network command, right? On R1, I'm using network command, and I'll advertise this 111 route on R1. So what this R1 router will do? This R1 router will send this route to R2, and this R1 router is also send this route to R3, right or wrong? Right? Okay. And let's say on R1, I'm using what? AS100. And on R3 as well, I'm using what? AS100. On R2, I'm using what? AS100, okay. Correct? In every router, I'm using AS100. It means the neighborship type is what? IBGP.
IBGP, correct.
IBGP. Because I'm using a same AS, correct? Okay. Now what happening? R1 router will share this prefix. I'm using a network command. Using the network command, I can advertise this route on R1. So R1 will share this prefix to R2. R1 is also sharing this prefix to R3, right or wrong?
I think so, yeah. Yes.
Should be.
Okay, because I told you the network command we are using to share the prefix, right? So on R1, I'm using a network command router BGP 100 and network 1.1.1.1 mask 255.255.255.255. Immediately, this R1 will share this prefix to R2 and R3. It means now R3 will receive this. R3 will receive 1.1.1.1 route /32. R2 router is also receiving 1.1.1.1 route. Correct? Okay. Now what this R2 router will do?
But between
this
R2 and
R2
R3,
router, R1 router will share to R2, and R2 is also sharing to R3, right or wrong?
No.
Should not.
It means right now what happening? This 1.1.1.1, it will be receiving from R1, and R3 will receive one more 1.1.1.1 route from where?
R2.
From R2.
And that's
right.
And that's
exactly same thing happen here as well. Here as well, R1 is also sharing this route to R3, and R3 is also sharing the same route to R1. It means R1 will receive 1.1.1.1 route from where? From R1, and exactly same this 1.1.1.1 route it will be received from R2, sorry, R3 as well, right?
Yep, exactly.
R3 as well. Now
It will
what
be
this
like
R2 router will do, this R2 router is also sharing the same route to R1, correct? So actually the
Yes.
problem is what? The same packet, it will be going like this, right? And
Yeah,
going
it's
like
like
this. So this is called what?
split horizon, like a loop. It's like
Loop.
the spanning
This is
tree and
what?
switches.
Yes, in spanning tree we have a loop. That's why we are using span STP to prevent the loop and to avoid the loop, right? Exactly same. This is called, again, it is what? Loop. The same route, this R1 router will receive the same route from different interface or from different side. So this is what? Problem, right? This is what? Problem. That's why we are making what?
Split horizon.
Split horizon rule, or we can say IBGP loop prevention mechanism to remove this loop. How it will be removing? Okay, I can explain you. R1, R2, R3. Now what happening here? Also I'm using AS100. Here also I'm using AS100. Here also I'm using AS100, right? Now let's say R1 router having a loop back, the same loop back, that is 1.1.1.1/32. Using the network command, I can advertise this route on R1 router. So what this R1 router will do? This R1 router will share this route to R2, and this R1 router will share this route to R3. And the neighborship type is what? That is IBGP. In this time, what happening? This R3 router will receive 1.1.1.1 route from where? From R1. And R2 is also receiving 1.1.1.1 route from where?
From R1.
From R1. Perfect. Now what happening? You know, I told what is the IBGP loop prevention mechanism says? IBGP loop prevention mechanism says when I receive any route from my IBGP neighbor, so same route I'm not able to share to my next IBGP neighbor. It means right now, once this R2 router will receive the route 11111 from which neighbor? From my IBGP neighbor. It means from R1. So this R2 router is not able to share the same route to R3, right? It means, and exactly same thing happen. This R1 router will share the route to R3 1.1.1. So R3 is not able to share this route to R2. It means using this loop prevention mechanism or using this split horizon rule, we can avoid this loop, right? Or we can say prevent this loop, correct? Okay. So it means, okay, just to tell me one thing. If I make this type of topology, then split horizon rule is what? Perfect, right? Because in this topology, what is the problem? The loop is created. That's why we need a split horizon rule, right or wrong?
Right.
Okay. But if we have this type of topology, like we have a R1 router and we have a R2 router and we have a R3 router, right? And this R1 router having a loop back 1.1.1.1 route/32, and using the network command, I can also advertise the route on R1. So R1 router will share this prefix to R2, and R2 router is not able to share this prefix to R3, right?
Correct.
So actually in this topology, there is no any loop, but still using the split horizon rule, R3 is not able to receive this route. So this is the problem in this topology. So in this topology, using the split horizon rule, the problem is what? R3 is not able to receive that route. But in this topology, the split horizon rule is working properly best. We can say in this topology, this loop prevention mechanism is best, right?
Okay,
But
so
in
for
this
example, so
topology,
if you can, so basically, if you do IBGP, the routers are in between each router, all they're supposed to be connected between each other directly to be able to
yes,
work it out. Okay,
yes. If we have this type of topology like this, then
it
we
works.
obviously we know the loop is created, and to avoid the loop, we have a split horizon rule. But in this type of topology, if I'm making and I'm enable the IBGP neighborship, so R3 is not able to receive that route because of split horizon rule. So it means we can say this split horizon rule is profitable for this topology, but not profitable in this topology.
So
right?
basically, split horizon is a rule. It's not like a command or something to prevent the loop.
No, it is not a command and something. No, it is a rule. By default, it is enabled.
So when you do the topology, you need to think about it before you do it. Like it's not like the spanning tree that you can actually put commands and do like
No, nothing. I also show you the practically that thing. Don't worry, okay? I'll show
okay,
you.
okay.
Wait. No need to enable any command or no need to enable anything else. This is the rule actually. By default, it enables. Actually, BGP protocol is very interesting, literally. Okay. On R1, I'm using what? Let's say the AS is what? 100, right? Okay. On R2, I'm using what? AS 100 again. On R3, I'm using what? AS 100 again. Okay. On R4, I'm using what? AS 200, correct? It means, according to my topology, the IP address is 10.1 here. And here it is what? 10.2. Here it is what? 20.1. Here it is what? 20.2. Here it is what? 30.1. Here it is what? 30.2. Correct. And R1 router is also having one loopback that is 1.1.1.1/32. Correct. So it means in between R1 R2 the neighborship type is what? IBGP or EBGP?
IBGP.
IBGP.
IBGP. And in between R2 R3?
Same.
IBGP also.
Okay. And in between R2 and R4?
EBGP.
EBGP.
EBGP. Great. So let's configure the BGP and let's start the devices. Okay, let's go on R1 and then configure IP address. Done. IP addressing is done. Now let's enable the BGP and make the neighborship. So let's go on R1 and then say router BGP 100. So neighbor is what? Tell me. Command. Neighbor.
Remote as 100.
What is the neighbor IP address?
192.168.10.2.
Okay. Remote AS is
Remote
what?
S 100.
Okay. Let's go on R2. And just to tell me on R2, I'll say router BGP say 100. Now the neighbor is what?
192.68.10.1.
Okay, remote AS is what?
Remote S 100.
Okay, and
then also the neighbor dot 30.2.
Okay, 30.2 and remote AS is
Remote
what?
as neighbor
200.
Okay, and then
also another neighbor is 20.2.
Okay, remote AS is what?
100.
Superb, superb. And now let's go on R3. And on R3, what is the command? Router BGP and then say 100. Neighbor is what?
I'm sorry. 20.1.
Okay, perfect. It's 20.1 and the remote AS will be what?
100.
Perfect. And wait for a second. Yeah, the neighborship is up, right? Okay. Let's go on R4 and then say what router BGP say?
200.
200. And then say neighbor, tell me.
30.1.
Perfect. It's 192.168.30.1. Remote AS will be what?
100.
Perfect. Now the neighborship is up. So, I told you always once you create a neighborship, also always we need to check the neighbors is up or not. So, I told you we have two commands. So the first command is what? Do show IP BGP summary. Yes, it will be show me the state will be blank. It means yes, the neighborship will be up, right?
Okay.
Super. Everything is fine. But if I'll check the BGP, if I'll check the BGP table, so I'm not receiving any route. Do show IP BGP. So I'm not using any route. Why? Because on R1, I'm not advertise any route here, right or wrong?
Exactly. Correctly.
So we need to advertise the route. I'll say network 1.1.1.1 and then say what mask 255.255.255.255. Correct? I'll say enter.
Correct.
Once I'll say enter, now I'll show you do show IP BGP. So yes, it will be showing this route 1.1.1.1. Correct?
Correct.
Okay. And on R2, it will be showing me the same route.
R2.
R2, yeah.
Do show IP BGP. Previously, they don't show me anything else, but now if I'm using the same command, so yes, it will be show me 1.1.1.1 I can receive, right?
Yes.
Okay. So just to tell me, R3 router will receive 111 router not?
Still not.
Not why?
Because of the rule.
Because of the rule, yeah.
Split horizon rule. Yes. And R4 will receive or not?
Yes.
Yes. Okay. So I'll show you on R4 first. Do show IP BGP. So yes, I can receive 111 route, correct? In the BGP table. And now if I'll show you on R3, do show IP BGP. So they don't show me that route.
So this is basically automatically. It detects when it's internal or external.
Yes, it is automatically. Yes.
Okay. Good enough.
Okay, this is by default rule actually. By default, it is enabled. Okay.
Okay.
So this is rule always. It's the rule is what whenever if I'm getting any route from my IBGP neighbor, so that route I'm not able to share to my next IBGP neighbor. Okay.
Okay. Got it.
But if the neighborship eBGP, then yes, I can share that route. Yeah.
Understood.
Clear? This rule is done. Perfect.
Yes.
So the IBGP loop prevention rule is done. Now the next is what?
Prevention loop.
We can also call
split horizon.
Split horizon rule. And here we have one more rule, that is eBGP loop prevention mechanism. Right now I told you what iBGP loop prevention mechanism. Now what is eBGP loop prevention mechanism is what? Okay. First of all, I can explain you first what rule of AS number or rule of AS we can say. Okay. Now,
Okay.
let's take an example. This is the rule number 1 here, and this is the rule number 2. So the rule is what? Let's say we have a router R1, and then we have a router R2, and then we have a router R3, and then we have a router R4, right? Again, R1, R2, R3, R4, right? R1 router having a route 1.1.1.1. Here also R1 having a route 1.1.1.1, correct? And on R1 I'm using AS100. On R2 I'm using what? AS100. On R3 I'm using what? AS100. On R4 I'm using what? AS100, correct? On R1 I'm using what? AS100. On R2 I'm using what? AS200. On R3 I'm using AS300. On R4 I'm using AS400, right? Okay. In this time, what happening? Once I'm using a network command on R1 and I'll advertise this route 1.1.1.1, immediately this R1 router will send what? 1.1.1.1 route to R2, right or wrong? Yes or no?
Correct. Correct.
Okay, perfect. Now they will check the in between R1, R2, the neighborship type is what? iBGP or eBGP?
IBGP.
iBGP. So if the neighborship type is what? iBGP, then they don't add this AS number. It means whenever if the device will send the route to R2, so they don't add the AS number, correct? Exactly same on R1. If I'm using a network command and I'll advertise this route 111, and if this R1 router will share this route to R2, so it will be sharing like this 1.1.1.1, and it will be adding what? AS 100. It means when the neighbor is what? eBGP, so they will
always share
the AS. Okay. And when the neighborship is what? iBGP, so they don't add the AS. Clear?
Okay.
It means R2, once this R2 router will share this route to R3, so R2 router will share like this 1.1.1.1. First AS is what? 100. And secondly, it will be adding what? 200 like this, and then share to R3. R3 will share to R4, so it is look like this 1.1.1.1. It means it will be adding the AS number one by 100, 200, 300, and it will be shared to R4. Clear?
Okay. Okay. So it's creating a path, basically.
Yes. Yes. In case of eBGP. So remember this rule, okay?
Of course. Okay.
Yes.
Cool.
It's very simple. In iBGP, they don't add. In eBGP, they will add. Okay.
Can you repeat that thing one more time?
Yeah, sure. Okay. So in this time, what happening? Let's go on R1. Okay. In the first topology, what happening? Right now, the neighborship is what? That is iBGP neighborship, right? Here also it is iBGP neighborship. Here also it is iBGP, and here also it is iBGP, correct? Okay. So let's say on R1, I'm using a network command 1.1.1.1, and I'll advertise this route 111. Immediately, what this R1 router will do, this route R1 router will share this prefix 1.1.1.1, correct?
Exactly.
And right now, in between R2, the neighborship type is what? That is
iBGP.
iBGP. So if the neighborship type is iBGP, in that case, they don't add our AS number. It means they will share only the route to our neighbor, correct? Okay. Now, in case the second topology, what happened? On R1, let's say I'm using a network command and I'll advertise this route 1.1.1.1. Immediately, this R1 router will share this route 1.1.1.1. Now, this R1 router will check neighborship type is what? eBGP or IBGP? The neighborship type is what? That is eBGP, right? So it will be checking what is my AS number, that is 100. So it will be adding what? AS number as well here. Okay, it means when the neighborship type is what? IBGP, so they don't add the AS number. When the neighborship type is what? eBGP, then yes, it will add the AS number. Okay, now once this R2 router will share this route to R3, so it is look like this, like 1.1.1.1, and the AS number will be what? That is 100, and now it will be adding 200 as well, our AS as well. It means the previous AS and the our AS number is also adding, so that is 100 and 200. Now once this R3 router will share the prefix to R4, so what it will be doing? 1.1.1.1, and it will be adding what? 100 plus, then tell me. Yes,
200 plus 300.
Okay, and then yes, perfect. It means once this R4 will receive, so it will be receive 1.1.1.1 with AS 100, 200, and then 300, correct?
Okay, understand.
And here it will be receiving only 1.1.1.1 this route. They don't receive any AS here to here, or they don't exchange the AS. It means in case of IBGP, what happened? They don't add the AS number. In case of eBGP, they will add AS number. Clear?
Clear.
Correct.
Great, superb. Now what I can explain you, actually, I can explaining you what IBGP loop prevention mechanism rule. Okay, what is the rule here? Let's say we have some routers R1, R2, R3, R4, R5, R6, R7, R8, correct?
Correct, Amando.
Yeah. Okay. On R1, let's say I'm using a AS what? 100. AS, again, it is 100. AS 200. AS 300. AS 400. Again, same AS 400. AS 500. AS 600, correct? Okay.
Yeah, in this case, it will all share the network because basically it's one jump IBGP, but then the next one is eBGP. So basically, it will advertise the entire network with the network
Yes,
protocol.
yes. So let's say on R1, I'm having a loop back that is 2.1.1.1.1/32, right? Okay, exactly same thing happened. On R1, using the network command, I can advertise this prefix, right?
Exactly.
So what this R1 router will do? This R1 router will share this prefix to R2. Okay, so just to tell
Yes.
me, it will share the AS number or not?
No.
No, perfect. But when this R2 router will share this prefix to R3, so it will be sending like this 1.1.1.1. With next hop is what?
eBGP.
100 and 200.
Sorry, yes, it will be adding what? 100 and then what? No, it will
200.
be adding only 100.
Oh, only
Because
100. Okay,
R2
next.
will,
100.
yes,
On the next
Okay,
one,
okay.
it
yes,
will be
R3 uses
100 plus
100.
200.
Yes,
Okay, got
yes.
it, got it.
Once it will be sending here, then it will be sending 1.1.1.1 and then what? 100
Plus
plus
200.
200.
200. Once
And the
this
same time,
R4 router will share to R3, sorry, R5,
100,
then this
100 plus
R5 will receive what? Like this 1.1.1.1, then 100,
200 and
200 plus
400.
300.
300, sorry.
300. Okay. Okay. Tell me R6 will receive what?
Yeah, it'll be 100,
Plus 200
200,
plus 300 plus 400.
300. Actually,
300?
Oh,
No,
actually,
no
no, not
400.
400.
Because the
Not
neighbor is
400.
what?
Yeah, it's
it's
IBGP.
IBGP.
Yes, the neighbor is what? IBGP. So here it will be
IBGP.
show me
Oh.
only 100, 200, and 300. Once this R3 will, sorry, once this R6 will share to R7, then it will be show me 1.1.1.1 with
100, 200, 300, 400.
yes. Okay. Okay, R4, exactly same thing, R7 will share to R8, okay. Now once this R8 will share to R1, so it is what? 1.1.1.1. Tell me the AS number.
100,
100.
200, 300, 400, 500.
500. And then 600 as well, because
Oh yeah,
R8 will share to R1
oh, okay,
now.
yes. Okay, yeah, got it.
Done? Okay. Now
Yep.
see, remember, very important point now. Now, what happening? Once this R1 router will receive this 1.1.1.1 route, and it will be checking first of all the first AS actually. So the first AS is what?
100.
100. And this R1 router will check what is my AS number?
100 as well.
It means this what this R1 router will think, this 111 prefix is advertising by me. And
Okay.
I also receive the same route from the different side. This is also what?
A loop.
Loop.
Oh, crap.
Right? No, because this route is originated by where? Which router will originate this route?
What one? Router one.
Which router? R1 router. Right or wrong?
Okay.
R1 router
Yes.
will originate this route is originated by R1, and R1 will receive the same route from the different interface. So what is the rule? When I'm receiving a same route from different interface with same AS, so this router will ignore this route. It means this router don't receive this route from here.
Okay.
And
So
that
this
is
is again
automatically. That is automatically.
That is
Right?
yes,
Never
automatically. This is again we have a rule. When this is the EBGP rule, actually EBGP loop prevention mechanism. Because when I receive this route, so this is called what? Loop. So to prevent this loop, what is the rule here? Whenever if I'm receiving any route, so that router will check the AS number. What AS number is there? Okay, the AS number will be the first AS. It will be what? 100. It means what? Once the first AS is 100, it means what? This route is originated by the same router. So now this R1 router don't receive this route. Okay.
Okay. Okay. Got it.
So this is what? BGP loop prevention mechanism.
Loop prevention.
Okay.
Exactly.
Loop prevention mechanism. So here we have IBGP loop prevention mechanism and EBGP. What IBGP says? IBGP says whenever I'm receiving any route from my IBGP neighbor, so same route I'm not able to share to my next IBGP neighbor. And what EBGP neighbor says? Whenever if I'm receiving any route from the same AS, right? So that route I'm not able to receive. Correct?
Okay.
Any doubt till now? Everything is good. So far, so good.
The good thing that this is automatically. It's not like the
Yes,
spanning
this
tree.
is automatically. Yes.
In spanning tree,
I
you
can
have to
show
do
you.
something
I'll show
manually.
you. Wait, I'll show
You
you
have
this
to
thing.
do it.
Don't worry. So how we can do how I can prove this thing? Okay. Here I'm using what? AS 100. Here I'm using what? AS 200. Here I'm using what? AS 300. Correct? So let's configure this topology. First of all, let's disable all the BGP in every router. I'll say no router. BGP say 100 on R2 as well. I'll say what? No router BGP say 100 on R3 as well. I'll say what? No router BGP say 100. Okay. On R4 we need to say what? No router BGP say 100. Correct? Okay. Now let's go on R1 and configure the BGP. So I'll say router BGP say 100. Okay, what is the neighbor? Tell me guys, neighbor.
Sorry, what? Sorry, I was writing down
192,
something.
168.
This is R1? Okay, it's
Yes,
10.
on R1. Yeah.
10.2.
Okay, remote AS is what?
200.
Okay, let's go on R2. And then say what router BGP and then say AS is what on R2?
200. 200.
Okay. And the neighbor is what?
Dot one, 10.1.
Remote AS is what?
100.
And now?
Neighbor is 10 dot, no, sorry, 30.2. We can start. We can say 30.2 or 20.2.
20 dot? Okay. Remote AS is what?
300.
Okay. Now the
And
next
the
neighbor?
other neighbor, it's 30.2.
Remote AS?
100.
100, right? Done. Neighborship is up. We need to check on R2. The neighborship is up or not. Okay, I think I'm not enable that command. Okay, on R2 it will be show me the error. What error? Do one thing. Let's make another topology. Let's say these are the ISP routers. Okay. This is R1 and this is R2, right?
Mm-hmm.
ISP1, ISP2, and these are the customers. Right? This is the topology. So let's go on R1. Done. On R1, we have a 10.1 and we have one loopback, right? Now let's configure this R2 router as well. Done. This is the IP address here. Let's configure the ISP routers. Okay, on F0 by 0, I'm using what? 10.2.255.255.255.0, and then say what? No shut, right? Interface F1 by 0. I'm using here what? 192.168, 99.1.255.255.255.0, right? No shut. Okay. Let's go on ISP2 router. Interface F0 by 0. On interface F0 by 0, I'll configure 20.2, right? Okay. Interface F1 by 0. Here it will show me the duplicate IP error. Show IP interface brief. Okay, actually here I'll configure 20.2. Sorry, I'll change the IP address 20.1.255.255.255.0 and then say no shut. Interface F1 by 0. And here we need to configure 192.168.99.1. Sorry, 99.2 is 255.255.255.0 and then say no shut. Done. So IP addressing is done. Right or wrong, guys? Have any doubt?
Okay.
Okay, super. Now let's go on R1 router and start the configuration, the BGP configuration, right? Okay, one more thing. On R1, let's say I'm using what? AS100, right? And on R2 as well, I'm using what? AS100. And here I'm using what?
Wait a minute.
AS200
AS. Okay.
and AS300. Right? So let's configure on R1 first of all. Router, BGP say 100. Neighbor is what? 10.2. Remote AS will be what? 200, right? Tell me.
Yes.
Okay. On ISP1, router, BGP,
Okay.
200. Neighbor is what? Tell me.
200. Neighbor is what is it? What's the IP? I don't see it. 10 watt.1. And it's 100, yes.
Okay. And the neighbor then?
And the other neighbor is 99.2.
Okay. You told me 99.2. Remote AS will be what?
Remote is 300.
300. Great. Now let's go on ISP2 and then say what? Router, BGP say 300. Neighbor 192.168.99.1. Remote AS will be what?
200.
200. And then neighbor 192.168.
20.1.
20.2.
Oh, sorry. 20.2. Sorry.
Remote AS will be what?
100.
100. And on R2, router BGP, say
100.
100. Neighbor is what?
20.1.
20.1. Remote AS will be what?
300.
300. So let's check the neighborship first of all on ISP1. Neighborship is up or not? So do show IP BGP summary. Can you tell me the neighborship is up or not?
Yes, because it's a blank.
Okay. And can you tell me on our ISP2 the neighborship is up or not?
Yes, we're both blank.
Perfect. That's fine. Now let's go on R1. I'm using a network command 1.1.1.1. Mask will be 255.255.255.0. 255.255. I say enter. Now, if I'll show you do show IP BGP, so can you tell me here will be show me 111 route, right or wrong?
Well, it's created.
Perfect.
Yeah, it's, I mean,
Yeah, superb. And
Okay.
on ISP1, it will be show me this route, right or wrong?
It is.
Perfect.
That's
Now let's
correct.
go on ISP2 to show IP BGP. Yes, it will be show me this route here as well,
That's
right?
correct.
But
Correct.
if I'll show you this route here, so they don't show me this route here. Why?
Mm,
Okay, I'll show you
because
ISP2 actually. To show IP
ISP,
BGP. So it will be receive this 111 route. And can you check it?
yes, the path is 200, 100.
So it means once this R2 will receive, so it will be show me 1.1.1.1. Once it will be shared to here, so it uses our AS because R1 uses AS 100 and ISP1 uses 100 and 200. So it will, right, that's why it will be show me here what 200 plus 100. And when this
100.
ISP2 will share to R2, so it will be look like this 1.1.1.1 and 200 plus, sorry, it will be sharing like this 300 plus
200
200
plus
plus 100.
100.
Now,
But
once this R2 router will receive this route
200.
111111, it
It
will be
will
checked.
move.
The first AS is what, that is 100, and I'm using
it
also
would
same AS, right?
it wouldn't work.
Mm-hmm.
That's
Wow.
why this R2 is not able to receive this route, correct?
Exactly.
Mm-hmm.
Any doubt, anyone? So please tell me.
No, everything pretty good now.
Superb. So I hope the reason is clear why this R2 router is not received the route, correct?
Mm-hmm.
But if you want to receive this route, so you can do that. How? Okay, I'll show you.
Oh, that's the way.
That's why
Yes,
I have
we
started
have
the
a we have a
beginning.
feature. We have a feature to
Mm-hmm.
use this command. Receive this route, that is what allows in do clear IP BGP star and then say soft. Now if I'll show you do show IP BGP, so yes, I can receive this route. Correct?
Oh, that's it. That's
So
you can
what?
do that if it's not the same router. But if it's the same router, it won't allow you to do that. Right?
Yes,
Good question.
you're right. Actually, what happening right now, like this is the eBGP loop prevention mechanism. But if you want to break this eBGP loop prevention mechanism, so yes, we can do that using this allows in command.
Okay. Let me write down
Okay,
that command real
take it.
quick. That's pretty
Yeah.
cool.
Yeah.
Hold on. Neighbor.
Okay, so you put neighbor. Neighbor.
By default, you are not able to receive. But if you want to receive, or if you want to break this eBGP loop prevention mechanism, then yes, you can do that using allows in command. Okay.
But in some cases, if you do it,
Allows.
you will create a loop, right?
Yes. Right now, loop is not created
Yes.
because
Exactly.
we know this route is
Different
not
router.
sent to
Exactly.
here again, right? So yes,
But
in this case, we can break that, right? So it's a condition. It's
exactly.
up to the condition, right? If the loop is created, then automatically it will be avoid that loop. But if it's not created, if you want to receive that route, so yes, you can do that. You can enable this command, and yes, that router will receive that route.
Exactly. This command will fail if you do it within the same router, like Hector said.
Yes.
Exactly.
Exactly.
Interesting.
Because sometimes what happening, if we have two branches, if in our company, if we have two branches, so obviously that branch will use the same AS, right? This branch is also using the same AS, and this branch is also using the same AS. So if I'm receiving that route, so I'm not able to receive that route. But if the second branch wants to receive that route, so that branch will use this command allows in, right? And can you see here, it will be show me 300, 200, and 100. Same thing I told you here, 300, 200, and 100. Again, if I'm using what? Know this command and then say what? Do clear IPBGP start soft. And now again, if I'll show the BGP label do show IPBGP, now I'm not receiving any route. Correct?
What is the command to clear?
Okay, the command is what?
Yeah.
Do clear IP BGP start soft.
Start.
Start SO.
Start.
SO, it means that is what soft. Why where is this
Soft.
command actually? Okay. in case of BGP, in case of